Yes.
Do they ever come and like take your remote to your TV? Because mine is just gone.
No,
No?
no.
Who can I contact? Because it was on my desk when I left Friday, and now it's gone.
You, call Alex, the head custodian, and see if we've asked.
Okay, Alex, what do you know his last name?
Locus, yeah, I have his cell number, I'll give you.
Okay. Can you just email it to me?
Yeah.
10 people came? How many people came?
For this class,
8 out of what?
30 something. Here's
That's a decent ratio.
I don't have any. It's like very little.
Isn't that like one out of every,
Around one every 3, one every 4, somewhere there.
one out of 4 people came? I need a better place.
My other one, my red one, you mean my red one?
Yeah.
Yeah, it kept on slipping out.
Is this exactly from that one? This is like literally $10.
You know how Apple really
And do your favor, this doesn't
Hey,
need
look like
protection.
this rather like. Just lean on this.
I'm gonna try.
Hi there.
Why buy one from Dollar Tree?
I mean,
Where you got an iPhone 15?
What? No. He fucking records what he's doing so we can see it on Google Classroom. Huh? He records what he's doing and posts it on Google Classroom. What else? And he will also be streaming on YouTube too.
Take it.
you got 21 subscribers.
I ordered them. They were on sale. I got an Apple cake, but it's in
I don't even know if it's on. It is. I think. Yeah, it is. Oh yeah, it does say it's live. It's live.
Last next door. Last next door.
That's kind of expensive, man.
He gets your lost
Shut up.
You should leave it right there. That's if I used to say that.
No, I did.
Yes. Yes.
Oh, it's a shadow? Yeah. I don't have the shoes for it. I'll go.
Right.
They don't care to.
Nah, bro. Nah. Yes. This nigga. So you got me up there like.
Hang on, sir, just in case the other two do something. All right, good morning. If you didn't grab the warm-up when you walked in, grab the warm-up. If you need paper for your notes, go grab paper for your notes. The warm-up is up here. Then I'll play the announcements.
Are you My mom said you want to go.
Oh, wait, no, we didn't.
Everybody has all the intelligences. There are so many factors such as hard work, practice, perseverance, and life
Alright, keep it down.
absolutely impact how these change and develop over the course of a lifetime. This tool is not meant to be definitive, but rather is just another way for you to learn more about yourself and how your strengths can help you guide you towards a future that will be fulfilling and successful. Using your device, please log on to californiacolleges.edu. If you haven't done so previously, please go register so that you have.
Alright, if you haven't registered, please register. We did this on Thursday, but I had quite a few of you absent. So go ahead and do that now. Go ahead and do that now. And it's californiacolleges.edu. Jordan, you're registered?
Yeah.
I'm gonna play this in about 20 seconds.
If you do have an account already set up, go ahead and sign in here with Google. Once you're signed in, head to the top tab called Career. Scroll down so that you can click on multiple intelligences. This assessment tool will take about 15 to 20 minutes to complete. Once you have completed it, the results will be saved. Go ahead and click on the results so we can see what your answers indicate. Depending on how you answered, you'll see which areas are stronger than others. Take some time to explore. Down at the bottom, more information is given about each of the strongest areas. You can go more in depth to learn about each of these by clicking the tabs along the top. As well, if you continue to scroll towards the bottom, there is a list of the top careers that relate to your survey results. These 9 intelligences are based on the research of a Harvard professor and psychologist named Howard Gardner. Let's learn a little bit more about each of them.
Number 1, linguistic intelligence. Linguistic intelligence is reflected in the ability of an individual to use a clear and effective vocabulary. This type of intelligence is common among writers, journalists, poets, and linguists, for example. Having lived abroad for a long time, I've met many people from all over the world, some of whom already spoke the new language fluently after a few months, while others still struggle after many years. The former are clearly endowed with superior linguistic intelligence. This type of intelligence is useful not only for writing correctly and learning foreign languages with ease, but also for skillfully conversing and speaking in public, always finding a way to translate even sophisticated concepts into simple words, and being able to understand and associate with great ease even the most complex terms. Number 2, logical mathematical intelligence. Logical mathematical intelligence is the ability to use logic to establish cause and effect links between various elements, and the ability to juggle numbers easily. This type of intelligence is typical of scientists, engineers, and technologists, for example. Those in possession of it love arithmetic, deductive reasoning, and games of logic. It should be noted that logical mathematical intelligence involves both cerebral hemispheres, the left one, which recalls mathematical symbols, and the right one, which deals with building and elaborating concepts. Young adults with lots of logical intelligence are interested in patterns, categories, and relationships. They're drawn to arithmetic problems, strategy games, and experiments. Number 3, spatial intelligence. Spatial intelligence is typical of sculptors, painters, pilots, and architects. This type of intelligence consists in the ability to perceive shapes and objects in space. Those who possess it normally have a developed memory for environmental details and know how to orient themselves in intricate places and recognize objects according to very complex mental patterns. This type of intelligence is particularly important for all those people who like to deal with planning and designing. Young adults with this kind of intelligence may be fascinated with mazes or jigsaw puzzles, or spend free time drawing and daydreaming. Number 4, body kinesthetic intelligence. Bodily kinesthetic intelligence is the capacity to manipulate objects and use a variety of physical skills. Those who possess this type of intelligence also have strong coordination skills. Athletes, dancers, surgeons, and craftspeople exhibit well-developed bodily kinesthetic intelligence. Number 5, musical intelligence. Normally, musical intelligence is located in the right hemisphere of our brain, but people with musical culture elaborate the melody in the left one. Those who have musical intelligence usually have a marked talent for playing musical instruments or for singing. It goes without saying that this type of intelligence is predominantly possessed by composers, musicians, and singers. Interestingly, there's often an effective connection between music and the emotions, and mathematical and musical intelligences may share some common thinking processes. Young adults with this kind of intelligence are usually singing or drumming to themselves. They're usually quite aware of sounds others may miss. Number 6, interpersonal intelligence. Interpersonal intelligence is the ability to understand and interact with others effectively. Those who possess it use their empathic abilities to connect with others and understand their fears, feelings, and needs. This type of intelligence allows those who have it to know human beings, to understand their motivations, and, if necessary, to manipulate them. Whatever type of intelligence you most associate yourself among the 9 explained in this video, this is probably the one that all of us should develop in some way, since it's fundamental in everyday relationships with others, both work-related and personal. This type of personal intelligence allows us to recognize the character and personality of those around us, to anticipate the behavioral reactions they'll have, and to act accordingly. Usually this kind of intelligence is found in teachers, managers, political leaders, and good entrepreneurs. Young adults with this kind of intelligence are leaders among their peers, are good at communicating, and seem to understand others' feelings and motives. Number 7, intrapersonal intelligence. Intrapersonal intelligence for an individual is the ability to fully understand oneself, including one's own feelings, one's fear, and one's weaknesses, in order to improve oneself to achieve one's personal goals. This is the type of intelligence that you can most develop by following this or other is common among actors, psychologists, and philosophers. These young adults may be shy. They're very aware of their own feelings and are self-motivated. Number 8, naturalist intelligence. Naturalist intelligence is typical of biologists, astronomers, and anthropologists, and indicates the ability to make relevant distinctions within the natural world, such as distinguishing one plant from another, or one animal from another animal, and so on. This ability was clearly of value in our evolutionary past as hunters, gatherers, and farmers. It continues to be central in such roles as botanist or chef. It's also speculated that much of our consumer society exploits the naturalist intelligences, which can be mobilized in the discrimination among cars, sneakers, kinds of makeup, and the like. Number 9, existential intelligence. The last in this list is existential intelligence, which represents sensitivity and capacity to tackle deep questions about human existence, such as the meaning of life, why we die, and how we got here. It's important to emphasize that this type of intelligence allows those who possess it to ask themselves these questions, but also to accept that the answers to these questions are partial, in constant evolution, and that they can't be simply grasped in a rational way. Existential intelligence is typical of philosophers, psychologists, and partly also of physicists. To conclude, we can establish that these different types of intelligence are more or less innate in individuals. They're not static and can be developed through exercise. Furthermore, if not kept trained, an intelligence can become weaker over time. So it's important to keep our brain in continuous exercise. As mentioned in the introduction of this video, knowing how to recognize the intelligence closest to our attitudes allows us to understand not only which studies to undertake to develop it further, but also how to use it in order to achieve a successful life.
Take some time to reflect. What are some things you learned about yourself through this career assessment tool? Did anything surprise you? How can this information help you in your future?
Alright, if you haven't done so, I highly recommend you register.
So it's important to undertake to develop.
Things you learned about yourself through this career?
Register on californiacollege.edu. Alright, take the assessments that they have there just to kind of get to know, well, just so that way it helps you select a career path or select a degree that you may find interesting, alright? It's to kind of match you up, alright? I know most of you are freshmen and you still have a lot of time, and that's, and you do have a lot of time, but being in high school, the time flies really fast, alright? Right now you're thinking, oh man, I'm trying to get through like this week, but you're gonna realize that you're gonna be a senior here soon, and it's gonna go by really fast, really fast. So, so do take the time to just do a little bit at a, just a little bit here and a little bit there to kind of get registered, build some interest in colleges and different degree plans. You never know where it may take you. You may be going to school across country in Florida just because it's like one of the few places that has a certain degree that you want. Alright, so do take some time to do that. Alright, let's go back to class. Cell phones put away before I start collecting. I'm going to be collecting the homework here. We'll do the warm-up. We'll talk about the warm-up. And then the classwork. If you were not here last week, you didn't really miss much. Because all we did was a benchmark for 2 or 3 days. Then we had foggy days. Right? Well, actually it was 2.5 because we had 2 foggy days. And there wasn't a whole lot we can do during a foggy day. And then the only topic that we're able to bring up was the arithmetic sequence, which is you're just adding to a list of numbers, right? You find what they share in common and add to it. Alright? So at this time, if you have your homework, I'll collect that. If you have your homework, get up. If you have your homework, I'll collect it. Some of you started turning it in online. If you turn it online, that's great. But if you have it on paper and you want to submit it now, let me collect that. Does anyone have it? In this class, I think I collected about 10 on Thursday, and then a few more came in, but I'm still missing quite a few. This is the first grade that's going in. I wasn't able to do the benchmark just because there were so many people absent. And I'm trying to figure out what's a fair way to give a grade for that assignment. And I will, it's just probably going to take me a couple of weeks where I can get everybody tested, or more people tested. Alright, nobody has it? Alright, let's just get started with the review then. With the warm-up. Geometric sequence. Alright, here we go. for those students that were out, I don't know if you were able to log into Classroom, but if you go to Classroom, you'll start noticing that there's links to my YouTube page, which what I'm doing is broadcasting live. The only thing you'll see on the YouTube page is just the screen. I've noticed that throughout the day, when the first day I did this, the students had it, so that way they don't have their head turned sideways or just watching YouTube, and watching the screen from the monitor. I don't mind you doing that, but I do expect some participation and some looking up at the board too. All right, we're ready? All right, let's begin. All right, so today we're going to talk about geometric sequences. All right, this is what we're going to cover. Kind of similar to what we did with arithmetic sequence. Now, for those of you who are not here, the notes, again, are posted on Google Classroom or on the website. The video's there. It's throughout it's my entire day, so it's going to repeat itself over and over and over. If you want to just catch one, just go to the middle and just catch the middle part of it. Just in case if I left something out in the beginning, you'll get it. And let's just say fourth period, all right? But it's all the same. All right, so the objective is to determine what a geometric sequence is, right, or not. Identify the first term and then the common ratio. The last time we did the common differences, right, the common difference. This time we're going to do the ratio. Identify the next three numbers that follow the pattern, and then write an explicit equation, right? Kind of what we did last time. So everything, the objectives still remain the same. The warm-up is going to be the same as the last time. Obviously, it's going to be two slightly different patterns that we're looking at, but same concept. Here we go. Let's start the warm-up. All right, so the warm-up you have these squares. It goes from having one square to now having a bigger square with like 4 tiles. We'll call that a tile. And then another one with 4 tiles, and then it increases by 16. All right. Now, can someone tell me how many tiles will be on the next one, or give me a description of how many tiles is its length and its width? All right. So what's the next one in the pattern? What's the next one in the pattern? Are you calling someone? All right, we call on Jordan. Jordan.
4 times the amount.
What? 4 times the amount. All right, so 4 times the amount. How many tiles is that? If you had to do it, and you can just do like the length and the width. You don't have to count all.
72.
72. All right, and you're pretty close. You're pretty close. Can anyone tell me? What? 64 tiles. All right, it's 8 by 8, so it looks something like this. So if you drew it, great. If you just counted and just wrote down the number, that's fine. Again, I'm just trying to see if you catch the pattern. You catch the pattern. All right, and Jordan said it already. What did you say again, Jordan? What was your answer? No, but before the first statement, the first statement you made before you gave me a number.
It goes 4 times the amount.
All right, it goes 4 times the amount. 4 times the amount. All right, here's the next pattern. I go from 2 smiley faces, 6 smiley faces, 18 smiley faces. What's the next one? What is the next one? Sebastian, what'd you get for the next? How many smiley faces did you get next? What's the next smiley?
30.
What? 30? Okay, you're close, but you're off by some. All right, go ahead, Andres.
54.
54. 54. How'd you get 54, Andres? Multiply by 3, alright? So you multiply by 3, you'll see that there's an increase, but not like, unlike the arithmetic sequence where we're adding, like we added 4, and then we're supposed to add another 4 for it to be arithmetic sequence here. The increase is going at a different rate. I go from 2 to 6, 6 to 18. What I'm doing is I'm multiplying by 3 each time. I'm multiplying by 3 each time. Alright, next. Alright, so there's one person. Next thing, there's 2. And then the next line below it, there's 4. So how many people be next? Or how many people are in the next line? How many people are in the next line? Alright, I'll call on someone. Tony, how many people are in the next line? So it goes from 1 to 2 to 4 will be the next one. So someone help Tony? Jessica, how many people on the next line? It goes from 1 to 2 to 4. 8. Alright, yeah, 8 people. Or 8 figures. Alright. So each person produces 2 more. Alright. Any questions there? Questions? Alright, ready? Let's start taking some notes. That's the warm-up. The warm-up, you'll keep the warm-up. You'll have that. You'll attach it to your notebooks, journals, whatever you use to take notes. Alright, if you want to use that paper to write notes in the back, you can. It's up to you. Alright, ready? Alright, so a sequence in which the ratio r can be multiplied to each term to get the next term is called geometric sequence. It's called a geometric sequence. Now, the arithmetic sequence was a difference that I added, right? Geometric sequence is a ratio that I multiply. So there's multiplication. Alright, so again, this is very similar to the arithmetic sequence. Arithmetic, you have A, you're adding. Geometric, we're going to be multiplying. I guess you could say the metric part of it, multiplying. The m in the middle, multiply. Alright, the ratio is called the common ratio. Common ratio. To find the common ratio, you divide like the 2 terms, right? I recommend dividing the second term by the first term. So divide the second term by the first term. If you want to write that down, go ahead and write that down. Let me get my pen out so I can write it. Alright, so what you're taking is your second term, and you're going to divide it by the first term. So you take the second term, divide by the first term. Second divided by first. Now, when you're doing this, you're going to get fractions. If you do not get an integer from your fraction that you create, then you are technically dividing. So if you get like 1/2, then you'll be dividing. You divide by 2. When you enter into the calculator, you can do one of 2 things. You put times 1/2, multiply by 1/2, or you can divide by 2. Divide by the bottom number, by the denominator. Anyone still writing? Anyone still need more time with this? Go ahead. Ready? Alright, moving on to, let's look at an example. What was it that one? I forgot to delete those. Here you go, so we're looking at this, 4, 8, 16, 32, 64, alright? 4, 8, 16, 32, 64. So, for those of you who are absent, the terms, A sub 1, A sub 2, A sub 3, that's just the terms in the sequence. A sequence is a list of numbers in a specific order. So here's my order, go from 4 to 8 to 16 to 32 to 64. What is happening each time? I'm multiplying by 2. I'm multiplying by 2. Alright? I'm multiplying by 2. How do I know I'm multiplying by 2? Alright, I can do one of two things. Use that formula I gave you. Take the second one, divide by the first one. 8 divided by 4 gives me 2. Or if you look at it, you can see there's a pattern that's being formed. When I go from 4 to 8, I add 4, but when I go 8 to 16, I'm adding 8. When I go 16 to 32, I'm adding 16. So each time I'm adding to the next one, I'm kind of doubling it up, right, from the previous. So when I'm double, I'm multiplying by 2. Any questions there? No? Is anyone still writing this? Let's look at a couple more examples where we had to find the first term and the common ratio of each geometric sequence. Alright, so example number 1, I have 2, 8, 32, 128, and 512. Alright, so that's my list. Alright, Nicole, what's the first term of that sequence? First term of the sequence. Nicole. What was it? I can't hear you, sir. The 2, yes, the 2, you are correct, the 2. Alright, the first term is the 2. Now to find the common ratio, Jordan, how would you find the common ratio? What's the common ratio here?
4
4? How'd you get 4? You're correct, it is 4.
by dividing.
By dividing, alright, by dividing, you take that second number, divide by the first number, 8 divided by 2 gives you 4. You're right. You are correct. Alright, any questions there? Questions? Alright, let's look at a different one. Number 2, I go from, here's my sequence. My sequence goes from 225, 45, 9, 9/5, 9/25. Alright. What is the first term on that one? Tyrone, what's the first term of this sequence? What's the first term? What's the first term of that sequence? The 200 and what? What's the first number you see? Well, the 2 is just the second example. So it's actually the 225. Alright, so it's 225. That's the first number in the list. Alright, now the common difference, the common ratio. What would be the common ratio here? Check off. Julian, what's the common ratio? If you need a calculator, go ahead and use a calculator. If you need one. What would you do to set this up? Take which one over which one? You're dividing two numbers, so which numbers are you dividing?
225 and 45.
Yeah, 225 divided by 45. Well, it's the other way around, 45 divided by 225. So 45 and 225, you divide that. Now, we're going to be using Desmo Scientific. If you type this into Desmo Scientific, so we're going to be using Desmo Scientific. When you type that in, 45 and 225. It'll give you a decimal answer. Alright, it's gonna give you 0.2 as an answer. But off to the side, there's gonna be a little circle and then a little square over the square. If you hit that key, it'll give you the fraction. So if I click on that key, my answer is gonna be 1/5, meaning I'm dividing by 5. Alright? I multiply by 1/5, or I'm dividing by 5. Now, however you want to state that, it'll be up to you. If you want to say I'm dividing by 5, that's good. However, when we make equations, you cannot put I'm dividing by 5. You have to put I'm putting down 1/5. 1/5. Alright? Questions? Questions there? Alright, so again, it is 1/5 or 0.2. If you want to put 0.2, you can put 0.2. It's going to be up to you. If you want to use a fraction or a decimal, it's totally up to you. Alright, any questions? Any questions? Questions? Alright, to find a common ratio, what do? Adrian, to find a common ratio, what do? Find the common ratio, what do? So what do, Adrian? To find a common ratio
For number 2. Right?
for either one, number 1 or number 2,
Oh,
what's the general step that you do?
Divide the second number by the first number.
Correct. So you divide the second number by the first number. You divide the second number by the first number, and that's how you get your common ratio. And that's the number I'm using to multiply each time. If it's a fraction, you're dividing, but if it's an integer, you're going to multiply. Alright, any questions? Questions there? And again, just a reminder, each time you do this, you gotta make sure it's gonna be the same all the way across. Alright? You can't be the same for the first two and then not the same for the second. Meaning, I cannot just multiply by 4 for the first two numbers and multiply by a different number for the rest of them. Alright, so let's look at one where you're doing the next three. The next three. So I go from 1 to 2 to 4 to 8. Alright, so let's see. What can I call them this time? Here. What's the, fill in the pattern. Fill in those dashed lines. So I go from 1 to 2 to 4 to 8. What would be the next? 16, okay, and then? Sorry. That was going to pop up here. So 16 is correct. And then? 32. All right, good. 16, 32. And then after that? Multiplying by 2, so what's 64? All right. Good. Multiply by 2. So we're not adding by 2, but we're multiplying by 2. All right, the next one. Here we go. We got some negative numbers. Negative numbers. All right, who wants to try this one? You might need a calculator for this. You might need a calculator, so if you want to go to Desmo Scientific, try to figure out the ratio, and then we're going to fill in the blanks. Figure out the ratio, and then fill in the blanks. All right, here we go. Sebastian, get you to answer this one. What's the common ratio, Sebastian? What's that multiplier? What am I multiplying by? By what? 5? 5 times 5 is what? 5 times 5 is 25. So does it go from 5 to 25? It goes from 5 to what? Here the jump goes from 5 to 15. So 5 to 15. So it's not 5 to 25 is 5 to 15. So it's a different number I'm multiplying by. What's that number? What am I multiplying by to get 15? 5 times what gives you 15? 3, alright? So if I take the second number, and I multiply it or divide it by the first number, I get 3. So 15 divided by 5 is 3. So my multiplier is 3, but it changes from positive to negative. So it changes from positive to negative. So it's actually going to be negative 3. So it's actually going to be a negative 3. So my ratio is negative 3. Alright, so negative 3. So R is equal to negative 3. So what we're doing is I'm multiplying by negative 3. Alright, we're live on YouTube so they can hear what you're saying.
What are God?
Alright. So here we go. So I'm going to go ahead and just have my calculator ready. Alright. Now let me have someone volunteer and give me the next number. Somebody? If not, I'm calling on someone. Anybody? Alright, Michael. You're going to need a calculator. So what's 135 times 3? If you want to be technical, what's negative 135 times a negative 3?
Negative 4. Yeah, 4 or 5.
4 or 5, it's going to be positive. It's going to flip from being positive to negative. So 4 or 5. So it goes positive, negative, positive. Alright, and then 4 or 5 times 3. What's 100 or 405 times 3? 4 or 5 times 3. Somebody?
1,215.
Alright, 1215. And then what's 1215 times 3? Good. 3,645. There it is. Alright, and that's how you find the next 3. Alright, that's it. Alright, let's get one more practice one. Alright, so I go from 4,000 to 2,000, 2,000 to 1,000, 1,000 to 500. So here I'm decreasing. Here I'm decreasing. So I'm not increasing, but I'm decreasing. So if you want to say you're dividing, you can say you're divided by a certain number. If you want to say you're multiplying by a fraction, you multiply by a fraction. Alright, what would be the next number? The next number. Cassandra, what's the next number? Alright, thank you, Cassandra. 250. Alright, Cassandra, what's the next one? Typing it in. What's the next one? 125, good. And then last, who wants to do the last one? What's the last one? Julian, what's the last one? Yeah, you're gonna get a decimal because it's 125. What's the last one?
65.5.
You're close. You're close.
Oh, 62.5.
Alright, 62.5. It's just half of 125, so you're just cutting each one in half. Half of 4,000 is 2,000, half of 2,000 is 1, half of 1 is 500, half of 500 is 250, and so on. Alright? So once we establish a pattern, then we go ahead and continue, we'll go ahead and solve for the rest of them, right? The ones that are missing. Alright, so from our objectives, we identified what a geometric sequence is, we found how to find the common ratio and the next 3 terms. Now is how to write an explicit formula. Alright, so looking at that pattern, 2, 8, 32, 128. Alright, the equation to write an explicit formula is, as you see on here, is you take the first term, which is a sub 1, and this time, instead of adding, you're going to be multiplying. Alright, so you take the first term, and then you're going to multiply it. It's not common difference, common ratio. I'll fix that here. But it's R for common ratio. This it didn't say when I was copying and pasting it. So it's common ratio. So switch this out to common ratio. And it's R for common ratio. Alright? And then the rest is going to be the same from the previous notes. A sub n is the solution, right, to a specific term, and n is a specific term. All right. Now again, like we did on Thursday of last week, all we're going to do is just set this up. That's it. Tomorrow we'll go in and we'll calculate, the 10th term or the 50th term or the 100th term. All right. We'll calculate those on tomorrow's class. All right. Today's class is going to be just kind of laying the foundation. We're just going to look at what's the first term, identify that common ratio, and then set up our equation. All right. All right, are there any questions there? Any questions? Make sure you do get this equation down because this is the meat of it, all right? This is what you, as high school students, as freshmen, or Math 1 students, as Math 1 students, you have to have this down. You have to be able to write it out. And then from there, you're going to make functions using this information. So make sure you have that. All right, any questions? Any questions? All right, let's do the assignments. So if you don't have paper, have separate paper from your notes. If you want to keep your notes and your assignment together, you can, but do not turn it in. Just keep it separate, or just take a picture and submit on the classroom.
Do you have paper?
That paper, yeah. If you need paper, I'll put it on the printer.
Thank you.
Yep. There's some up here, if you need paper. We've got some. Just grab it for yourself. Let your classmates grab their own. Alright, here we go. Again, I'll do like the first two problems, then you do the next two. Alright, number 1. I'm looking at this sequence. It goes from 2 to negative 72, 2 to negative 12, negative 12 to 72, 72 to 432. Alright, there's positive, negatives, that's fine. You have positive and negatives, that means I'm multiplying by a negative number. So my common ratio is negative. Now we have to determine what is that common ratio, and we got to make sure, is it the same all the way across? Alright, we have to determine what's the ratio, and then we have to determine is it common all the way across. Alright, who wants to take a shot at this one? Let's find the ratio first. How do we find the ratio? How do we find the ratio? Anybody? Anybody wants to take a shot at this? Alright, here you go. Let me call on someone. Let's see who's gonna talk today. Devin. Devin, how do we find the common ratio again? How do we find the ratio? We take two numbers and we do something to it. What are those, what is that operation? What do we do? You don't know? Who can help Devin out? Anyone? Tyrone? You have two, you have a list of numbers, I need to find the common ratio, so what do I do? There's a specific operation I do with two numbers. If you have a cell phone out, I'm gonna collect, so you better put them away. What's those two, what's that operation we do with two numbers? We just talked about it in the notes. What? Go ahead, Ramiro.
Take the second and divide it by the first.
Alright, take the second term, you can divide it by the first. Alright, so I have negative 12, and I'm going to divide it by 2, by the first. Negative 12 divided by 2 is what? Negative 6. So I got to make sure that all these when are multiplied by 6, by negative 6. 2 times 6 is 12, that's yes. 12 times 6 is 72, yes. 72 times 6 is 432, yep. So this is, yes, this is a geometric sequence. Alright, so this is yes, a geometric sequence. It does work out. Because I'm multiplying by, I'm technically multiplying by negative 6 each time. So yeah. Alright, I go from positive, negative, positive, negative. So that's good. Alright, second one. Second one. I go from negative 7 to 23. And then 23 to 127, and 127 to 623. Alright, and it goes the same, it goes negative, positive, negative, positive. So it's going to be a negative number. Alright? This one we might need Desmos to do this. Alright, so what I'm going to do is I'm going to take 23 and divide it by what? By 7, right? So by negative 7. Now, you can get a decimal answer. If you want to use a decimal, that's fine. And then take that answer and see if I multiply 23 times that decimal answer, does it equal negative 127? It has to be a perfect 127. It cannot be rounded. It has to be a perfect 127, which it does not. So this is no, not a geometric sequence. All right. And just because you get decimals doesn't mean that it's not going to be a geometric sequence, but the likelihood for this class, the likelihood is going to be very slim. Right? It has to, well, let me put it this way. If the decimal is not clean, if you get a decimal like a 0.5, 0.2, those are clean decimals, 0.25, right, has a stopping point, then we're good. All right, go ahead and do the next two. And it's just a simple yes or no. So yes is the geometric sequence because I'm multiplying each time, or no, it's not. Just that's all that's the only way you're answering this. All right, so you look between the two. Am I multiplying by 6 each time? By negative 6 each time? Yes, I am. On this one, am I multiplying by 23 over negative 7 each time? No, I'm not. So that's all you're doing. All right, you're going to answer 3 and 4. 3 and 4. You're answering 3 and 4. And again, if you use Desmos Scientific, use it on your Chromebook. Use it on your Chromebook, not your cell phones. You cannot use cell phones on a test, but you can use your Chromebook on the test. All right, you are doing 3 and 4. 3 and 4. By the way, this worksheet is posted on Google Classroom. Make sure you got it. All right, let me give you a hint. One's a yes and one's a no. You got to figure out which one's which. So 3 and 4. to jump to 5 and 6. If you didn't do 4, that's fine. You can go back and do 4. All right, let's look at this 5 through 8. 5 through 8. Again, one problem on 5 through 8. It's not a geometric sequence. So you'll say no, but the other 3 are. All right. So here we're just trying to find a common ratio. So we're going to first determine if it's a common. If it is a geometric sequence, if so, state the common ratio. What is that common ratio? All right, let's start with number 1. Let's start with number 1, or number 5, sorry, number 5. I have -1, -6, -36, -216. All right? So I'm multiplying by a certain number. It's going to be a positive number because the negative doesn't switch. Right? Negative times a negative is a positive, and then positive times a negative turns it back to a negative, right? So there's not a switching, like number 6 is a switch. Negative, positive, negative, positive. Here it's just going to be I'm multiplying by a certain number. All right? So who wants to take a shot at number 5? Number 5, number 5. Who wants to do number 5? If not, I'll call on someone. Jordan? All right, Jordan. Number 5, is this a geometric sequence? Yes, no? If so, what's the common ratio? All right, yes, it is. What is it multiplied by each time? It's multiplied by 6 each time. All right, times 6, times 6, times 6. So yes, and the ratio, we just put R equals positive 6. So I'm multiplying by 6 each time. All right, you might need a calculator just to test each one. 36 times 6, 216. All right, number 6. Number 6. I go from negative to a positive, negative to a positive. So here, my ratio is going to be a negative number if it is a common ratio. All right, so now, is this a geometric sequence? Number 6. What?
No.
No. Why not? What's the first multiplier? What am I multiplying the first time? So I'm multiplying by what? It is a negative number, but what is it? 4 times what gives you 12? 3. All right, 4 times 3 gives you 12. So I'm multiplying by 3. Now we got to figure out, when I multiply 12 by -3, is it going to be -36? 12 times -3 does give me -36. So we're good there. Here's the first one. All right, then we got to take 36 and multiply it by -3. So times -3. All right, this is the last one to test. When I multiply -36 times -3, am I going to get 108? Yes, I do. So this one's a yes. And my R is going to be -3. So I'm multiplying by -3 each time. All right. Are there any questions to this point? Any questions? All right, again, arithmetic, you're adding. Geometric, you're multiplying. So you got to figure out what is that multiplier? What's that ratio between each number? All right, I'll let you do 7 and 8. And again, one of those is going to be a no. So you just put no, you don't have to do any calculations or anything. So 7 and 8. work on, I'll walk around. Make sure at least you have the tape. Alright, so one of them is gonna be a yes on 7 and 8. One is gonna be a no, so you gotta figure out which one's which. You have any questions, raise your hand. The worksheet's online. Yeah. For the classroom, let me get it. You should, I don't know if you can access it through Aries. If you go on Aries and see if you can get it. If not, write it down. Yeah, see if you go through Aries because it's not. I have to log into one of the computers. Are you doing 1 through 8? You're doing 1 through 8? Were you able to get through Aries? You got it? And then the assignments there, the first two are there. So the first one, you could either print it out, just write it on paper, whichever one, and submit it on there, or you can turn it in, like the paper copy, and send me however you want. Take it either way. Alright, then move on to the next one. Alright, the next one, we're finding the next three. What are the next three numbers that follow this sequence? Alright, here there's no trick to it. You're just gonna find the pattern. Find what's the multiplier, and then from there, you're just going to multiply by that number. Alright, ready? So the first one, I go from -2 to +4 to -8 to 16. So it's going to be a positive, negative type rotation here. All right, what are we multiplying by? What's that number we're multiplying by? By what? By 2. All right, we're multiplying by 2, right? To be more technical, we're multiplying by -2. So what's 16 times -2? 16 times -2. 16 times -2. Anybody? 16 times 2. What's 16 times 2? 32. Alright, so -32. So we just find my pen. Here it is. So -32. And then what's -32 times 2? What's -32 times 2? And then this will be 64. Alright, and then 64 times 2. Gonna be negative what? 128. Alright, so again, you just take 16 times -2. That's how I get my -32. Take -32 times -2. That's how I get my +64. You take your +64 and you multiply that by -2. And you get your 128. Negative. Alright, questions there? Questions? Alright, we do one more and then you're doing the rest. I go from 3 to 6, the 12 to -24, or 3 to -6, to +12 to -24. Alright, what's the multiplier here? What's the multiplier here? Connie, what's the multiplier? What am I multiplying by?
3.
You're close. It's off by 1.
4.
The other way.
2.
2. Alright, so I'm multiplying by 2. Right? So I'm going to multiply each of these by, technically it's a negative 2, but I'm doubling in size, and then I just switch the signs. Go from negative, positive, positive, negative each time. Alright, so I'm going to multiply by 2 each time. Alright? So 24 times 2. What's 24 times 2? 24 times 2 is 48. Alright, and then 48 times 2. If you need a calculator, go ahead. Use your calculator. 96, but this 96 is going to be negative because we have to switch signs, positive, negative, negative, positive. And then what about 96 times 2? 96 times 2 would be what? Positive 192. Alright, and each time I'm multiplying by 2. Alright. Negative 2. Alright, just try to find the pattern or the ratio or the ratio, and then just multiply. Go ahead and do 11, 12. 11 and 12. Be about 30 seconds to do at least one more. And then I'm going to move on to 13 here. Let me give you about a minute. You're not going to put up your Chromebooks, you're just going to leave your Chromebooks there. So we're just going to use all the way to the end. All right, you're doing 11 and 12. Again, there's no tricks here. It's just what's the common ratio, and then find the next 3. If you haven't used Decimal Scientific, please start using it, because tomorrow it's just going to be all calculation, and I want you to be familiar, comfortable with Decimal Scientific. That is your SBAC calculator. I want you to feel comfortable using it. All right, number 13, here you go, number 13. All we're doing is just setting up the arithmetic sequence. We're not going to simplify it. We're just going to leave it, set it up, and that's it. We're not going to do any calculations, anything like that. Just a simple setup and move on. All right, we're ready? Number 13. All right, in order to answer these, or in order to come up with an equation, what you need is a formula. Alright? The formula A sub n is equal to A sub 1. A sub 1 is your first term times the ratio, and then raised to a power. I'm going to go ahead and put this in parentheses, n minus 1, because if we use a calculator and we're typing in a number there for n, you need to have that in parentheses. So n minus 1 in parentheses. Alright, ready? So let's just fill in the blank. So we're not solving for anything, any specific numbers, right? So A sub n is going to remain, and then the n minus 1 in parentheses is going to remain. All I need is two numbers. Alright, the first term. What is the first term here? Negative 4. So my first term is negative 4. Times the ratio. The ratio is, what's the multiplier between all these? What am I multiplying by? By 5. Multiplying by 5 each time. Alright, so 5 is my ratio. And then it's n minus 1. And that's your answer. -4 times 5 to the n minus 1. And the n minus 1 is an exponent. And that's it. That's all you're doing for all these problems. Let me do one more. Pick a number between 14 and 18. Any number between 14 and 18. Number 18. All right, number 18. All right, so here you go, 18. All right, so a sub n is equal to the first term. What's that first term? What's the first number of the sequence? First number of the sequence is what? 3. Times the ratio. What's the ratio? What am I multiplying by each time? What's the number that I'm multiplying by each time? If you don't know, just take the second number and divide it by the first number. By 2, right? It's going to be a -2, so I'm going to go ahead and put -2. Now, when you're using a calculator, when you're typing this to Desmos, anytime you have a negative and exponents, you want the base to be in parentheses. So, -2, -2 in parentheses, and then n minus 1 in parentheses. And the reason being is because you want the calculator to carry the negative with the 2 each time you're taking it to the next one. Those other dashes out there were mistakes. That's the eraser. Alright, so don't worry about this negative out here. This negative out here doesn't belong. Alright, any questions? Alright, you'll turn this in tomorrow. Make sure you do turn this in. Alright, have a seat. Bell's not going to ring for another 30 seconds. Have a seat. Alright, we're not leaving until everyone's sitting down, so take a seat. Tyrone, take a seat if you want to leave. Find a chair. Alright, please do not fall behind. Submit the warm-ups are yours. Do not fall behind. Submit your assignments. Alright, good morning. Okay, do you want me to print the notes for you, or do you prefer just to write them?
I don't know.
It's up to you. I mean, you still write them all. But how was your day so far?
I'm gonna take you with me down to the small business
You're downstairs.
and then I'll have to go back upstairs. That's that home take thing, they give you a key, I was like, you know.
Yeah, they're supposed to give you one. So they will. As soon as they,
She said it, she might come.
yeah. Well, you're supposed to, yeah. That's all that for review. Now your seat is, if you want to take a seat, you get the exact number. I want to say it's 13. Okay. Is that printed? Save. You don't have to stand up. You can sit. Oh, you can sit. Yeah, number 13. Right, right there. That's fine. That's fine. Well, the Chromebooks are there with the numbers, so you just find Chromebook number 13. That's your number. That'll be your Chromebook number. Well, I'll post them. So. Yeah. Right there. Right there. Yeah. So how's your day? How's your weekend? Did you do anything?
My dad like, people were crying at the football game, so that means,
Oh, yeah.
cause my team won, so.
Your team won? That's nice. You're a 49ers fan? I'm a Cowboys fan. I was so mad. Well, but actually I turned it off. I was like, I couldn't watch any more of it. So I turned it off like during halftime.
And I was scared, cause they stopped, and I was like, oh.
Yeah, they almost came back and won, but they shouldn't have won. If they won, oh, it would have been bad because they didn't deserve it.
What?
No, the Cowboys.
Oh, I was
The
like,
49ers, they deserve to win that game. They played a lot better. No, wait.
half of my family is not really friends, so when we all get together, we'll all shove it in our faces.
Yeah. Next one's gonna be tough. Green Bay.
So good.
That'll be a tough one. The paper will be, but it depends.
Because I see how they play, I'm like, oh.
I don't root for the Cowboys, I root for the Raiders. My California teams. But I'm from Texas, so I have to cheer for the Cowboys. Alright, get your warm up. I'll leave it there. Yeah, so say grab a warm up here. G here, don't know, G here. Grab a warm up, grab a warm up. Alright, morning, grab a warm up, it's right here. Just- Grab a warm up. There's no change to this, it's just the.
Guys, my thing's up to you.
Alright, what was I gonna grab?
What are you looking at? That's how you trick.
Raise your mask. Sore?
Yeah.
Yeah, I can.
Hey, lot over.
Huh?
You did that big Christian back there. I forgot.
What you do? You get some mouse spot. You what?
Cece's back? Hey, Cece's back?
Who's that?
Cece's back or what?
Who's that?
Hey, Eden. He's back? Huh? Cece's back?
Hey, question. Are you gonna move it face towards the screen? The screen over there?
So what? I'm gonna move it, yes. Eventually, waiting for more people to come.
I got some money.
Or they don't walk in.
Like, move you, Cece?
Look at slumber.
Nah, just stay there.
You want me to do it?
Yeah.
What the hell?
What?
Look, show me.
What is it?
What the hell? Look at that.
You dyed your hair or what?
You think I did?
Ricky, bro. Oh, it's watching. Oh shit. I don't even know what you mean.
You did the homework?
Brittany got her Steven home.
Put me here. That's not much help.
Wait, what homework? What homework?
We had from Thursday.
You turned that in, remember for
This is it.
you turned that shit in on Friday.
Yeah.
How many questions was it?
Like 18? Yeah. Honey, the homework was like 18 questions. We're in here too.
I have 30 seconds.
You didn't do it? No, I meant
It's
to.
due today? How much
Yes,
is the day?
we did it.
30 seconds.
I turned it in on Friday.
You came Friday? You came Friday?
Yes, I do this.
You came on Friday, too? It was easy? You learned stuff?
We didn't do nothing. Oh, we didn't do nothing for this time. We gotta sit anywhere.
What are we doing today? The same thing as Thursday?
Similar to Thursday.
And you know Mariah? She bought her BB belt.
Alright, so Alright, good morning, good morning. Alright, real quick. If you did not pick up a warm-up, come pick up a warm-up, you need paper for your notes and your assignment. It's here on top of the printer. Alright, go ahead and work on your warm-up, I take attendance. Silent, warm-up, I take attendance. Talent, let's go, come on. Yes.
I got a pencil yet?
Yeah, you need to sharpen it. Sharpen it back.
Oh, thank you.
Yeah, we don't have it ready.
Yeah, that was fancy.
Alright. Here we go.
What did you do this week?
Watch a little football.
Wait, who's your favorite football team?
Cowboys.
Oh, sucks. That sucks. That sucks.
How do you ask that question? You know I'm from Texas.
At least now, Cowboys versus Rush.
So I,
No, Dak threw that game.
yeah, it was bad.
If he didn't, he should have ran out of bounds. But he slid.
It's alright.
And then, of course, he gave the ball to his center, not to the ref.
G is still out. Shreve's here.
I don't get the top.
Alright, G and Amelia. And then who else we missing? John Williams. Jonathan's here. Then we're missing two. Kadesh.
Did you just transfer?
Alright, hopefully, the warm-up, again, if you wanna draw up the pictures, you can. Or if you just wanna write in how many squares, how many smiley faces are next. Alright, for those of you who are absent in this class, all we're doing is just looking at patterns and then trying to figure out what's the next one that goes in to fulfill the sequence or the pattern, alright? Let me just submit the attendance online and then we'll get started.
Are we going back to online school?
No, there's some talk about it, but it's just gonna be for like maybe a couple of weeks. But right now, we don't know. And a lot of it has to do because the teachers are
Oh yeah, that Miss Gonzalez teacher, she's been gone for like weeks.
yeah, we have a couple of teachers, or a few
Oh,
teachers, quite a few teachers.
I really hope we don't go back to online.
Like I said, if we do, it's just gonna be like for 2 weeks, just so the teachers can get better.
That's what they said last time. I know.
Yeah, but last time we didn't know.
Oh yeah.
Last time we did not know.
Yeah, they were like just 2 weeks.
Yeah, we thought it was.
Took like, for the first one we're supposed to, is it multiplying by 2 on each side?
Yeah.
That's what I thought.
No, just right.
Alright, just a reminder, we're going live on YouTube
Like you weren't.
for the students that are absent.
You were not in the. You were not in the.
Don't worry, it's not gonna catch any students' faces. The only person it'll catch is, Talent if he raises his hand, that's it. And you'll just see his hand.
Zodiac sign is your sorry.
Thank you.
Alright, here we go, let's go ahead and we begin.
I don't know.
I don't know them either.
What's mine?
It's like. May 17.
Alright, here we go. Alright, right, good morning. Let me have your attention over here. Over here. All right. So, for those students that were out yesterday or Thursday, all right, let's pay attention right here. Wyatt, look here, please. All right, Alexis, look here, please. All right, for those students that were out last week, if you miss a day, if you go on the assignment we're doing for that day on Google Classroom, you're going to notice that there's a link for the website, for the YouTube website that we have, and it'll broadcast the lesson from there. All right, let's pay attention out here. We'll broadcast the lesson, and again, it's just an experiment for the next 2 weeks, see how that goes. We have quite a few COVID cases out there, so hopefully you don't fall, if you do have to stay home at the quarantine, you don't fall too far behind, because you just wake up, watch the class, and then move on. Yes, Tyler?
Why isn't every class?
Why isn't every class doing it? I don't know. That's something that would be, I don't know. Every math class is going to do it, but we're just kind of experimenting with it right now. But we should, and we'll figure out a way. All right? For those students that are out, again, if you want to catch the classes there, go back, watch the notes. You can do that as well. Last week we talked about arithmetic sequence. All right, well, let me backtrack. For those students that were out last week, you really didn't miss much. You only missed one lesson. We had 2 foggy days, and we did benchmark testing. All right, so you really didn't miss a whole lot. You will make up your benchmark hopefully in the next 2 or 3 weeks. For those students that are out or were not able to complete the benchmark, you will have time to complete that in about 2 weeks. But what we did cover was arithmetic sequence, and we looked at patterns or a list of numbers, and we try to figure out what is the common difference, what is being added or in some cases subtracted to fulfill the next 3 numbers, or to find or to create an equation. All right, that's what we did the last class. All right, for instance, if I go 8, 10, 12, 14, if I ask you to continue with that pattern, you'll count by 2s, right? You'll continue by saying 16, 18, 20, right? And then we'll come up with an equation for that. So that's what we did last class, or on Thursday. Friday was a foggy day. All right, so we're going to continue with sequence, but this time we're going to be talking about geometric sequence. All right, geometric sequence. If you want to title your notes, geometric sequence. You don't have to write down the objectives. The objectives, it's basically the same as arithmetic sequence. You do not have to write that down. But what we are doing is going to determine if the sequence is geometric or not. We're going to continue to identify that first term. This time, we're going to find the common ratio instead of the common difference. Then we're going to identify the next 3 terms, and then finally we'll end the class by writing an explicit equation. All right, so again, title your notes, geometric sequence. If you need paper for your notes, raise your hand, stop by, paper. All right, so geometric sequence. One is for the notes and one's for this.
Wait, one for another one?
The one about your TV.
Wait, one
By the way, by the way, for those of you who did not turn in the arithmetic sequence assignment, raise your hand, I'll come by and pick that one up.
I turned mine in all the time.
Yeah, some of you turned it in, but quite a few of you did not. The arithmetic sequence assignment.
Your grades are so cool, babe.
All right, put the cell phones away. Okay? Yeah, so, there's two class. Alright,
Oh, you're.
anybody else? Anybody else?
Oh,
Arithmetic
sorry.
sequence?
Cannot talk.
Alright. Alright, here we go. Let's begin. Let's start with answering the warm-up questions. Alright, so on the first warm-up question, first warm-up question, I have 3 figures, one square or 1 tile. Then we go to 4 tiles, then 16 tiles. Alright? Now, there is something going on each time. There is something going on each time. Can someone tell me what is going on? Alexis, go ahead.
It's like multiplication.
It's like multiplication, alright? Yes, it is like multiplication. Alright, so how would you draw the next figure, or how many tiles would be in the next figure? Hold on. Forrest, go ahead.
64.
64 tiles. Alright, does anyone disagree with Forrest? Anyone disagree with Forrest? 64 tiles. That is correct, 64 tiles. What we did was, Tyler, what did you do again? To get
Times 2 every time.
times 2 every time, right? I doubled the height and I doubled the width, right? The length and the width. And if I were to count those tiles, 64, right? 8 times 8. Alright, good. So I multiplied by 2. Alright, let's look at the second question. I have 2 smiley faces, 6 smiley faces, 18 smiley faces. So this is the first term, second term, third term. What is the fourth term? What's the next term? How many smiley faces do I have?
54.
Elber, what?
54.
54. Does anyone disagree with Elber? 54. No one disagrees? Everyone agrees. All right, so since everyone agrees, how did you get 54? How did you get 54? Jose, how did you get 54? Yeah, multiply by 3. So I tripled, right? 2 times 3, 6. 6 times 3, 18. 18 times 3, 54. Alright, so I multiplied by 3, that's how I got 54. By the way, you don't have to draw 54 smiley faces. If you just want to write 54, that's fine. If you draw them out, you could draw them out. Good. Some of you drew them out, so it's good. Alright, next one. Next one. Here we go.
It was multiplied by 3.
Yeah, multiply by 3 for number 2. Alright, next question. Here we go. Alright, so here I have a person, or a figure that looks like a person. Then it becomes 2. This 2 becomes another 2. This person becomes another 2. So how many would be on the layer, the bottom layer here? 8. 8. Alright, so each person, you just draw 2 more. So you'll draw 2 for this one. You'll draw 2 for that one, draw 2 for that one.
Oh, yeah.
So you get 8. Alright? That's how you get that. Alright? Any questions there? Questions there? Questions there? Alright. That's your warm-up. The warm-up you'll keep part of your notes. If you want to write your notes on it, that's fine, but that is your notes. I meant to change the word on this slide because there's a grammar error. Alright, so let's talk about geometric sequence. What is a geometric sequence? A geometric sequence is a sequence in which a ratio, and this time we're using the letter R, can be multiplied to each term to get the next term in the sequence. Alright, so go ahead and write this down. This is the vocabulary for geometric sequence, or the definition for geometric sequence. Alright, so geometric sequence is a sequence in which a ratio R can be multiplied to each term to get the next term. Alright, so like arithmetic sequence, where we have a common difference, we use the letter D. the difference between geometric here is that instead of adding, we're gonna be multiplying, alright? So we're gonna look at a sequence. That sequence may be either increasing or decreasing. And if it is increasing, I'm gonna be multiplying. Or either way, I'm gonna be multiplying, alright? I can either multiply by an integer or a rational number by a fraction. If I multiply by a fraction, that means I'm dividing. Right, but we'll keep it simple, we'll keep it clean if it's a rational number. Alright, so again, a geometric sequence is a sequence in which R, that's the common ratio, can be multiplied to each term to get the next term.
What?
So that's a geometric sequence.
Okay, what fraction?
So what?
I write stuff down.
Yeah, this is the notes.
Can I have paper?
Yes. So this is a geometric sequence. This is the notes for it. All right, the next term. Sure, do you have paper? All right, the next one is,
Wait, not done.
go ahead, it's still the same page. Common ratio. Right, the common ratio, that's in the last class, on Thursday, we said the common difference, because that was the difference between each term. Here, we're looking for a ratio that they share in common for each term. Alright, so the ratio is called the common ratio. They have to be the same number that I'm multiplying, let's say multiplier, in order for it to be a geometric sequence. I cannot multiply by 2 on one between two terms, and then multiply by 3 for another term, and then multiply by 2 again, so it all has to be the same number that I'm multiplied by. You're good. Alright, so it's common ratio. Now to find the common ratio, you're dividing by 2 terms, right? And I'll write this out here on the bottom. So you're going to be dividing by 2 terms. Alright, we're going to do.
What was on the internet?
Alright, so to find the common ratio, what you need to do is divide by 2 terms. So divide by 2 terms.
Wait, so you could divide by any number?
Really, yeah, you divide by 2 numbers, but you have to go one after and then the one before. Trying to, I don't know why my hand's not working. Alright, I'll have to write that formula on, let me see if I can. Let me see if I pull this up really quick. It wasn't turned on, that's why. Oh, I need to find my writing tablet. might have to use the mouse to write because my writing tablet is not working. I have to do a reset. No, it's not. Do a reset. Alright, so I'm going to use my mouse. Alright, so you divide by two numbers. Alright, so those two numbers are as follows. It's the second term divided by the first term. Second term divided by the first term. So you put a sub 2 divided by a sub 1. I know that's really small. So I'll write it here. Second. So the second term divided by the first term. So a sub 2 divided by a sub 1. You'll see it again, but it's going to be kind of small. Alright, so the second term divided by the first term. And mouse upwards.
Is that A4?
A1. This is the A1.
Just broke or what?
So A sub 1. My computer's restarting.
You're one of those, man.
Hold on, I don't know what happened to my computer, it just shut down. It just shut down, so your computer's restarting for you. Alright. Let's check this out.
Shell shockers.
Shell
shockers?
Yeah.
What you want to go to?
Oh, the one that.
Shell shockers bring back memories.
Dude,
They block.
I thought they blocked it.
the joysticks are so hard. The joysticks are so hard.
For what?
It's so hard to move.
Shell shockers is easy.
I thought they blocked it.
Like,
You go on Iogram.
Iogram?
Go on the unblock one.
Yeah.
Why you raising it up, huh?
what? Oh, yeah.
Alright, I got it working now. Yeah, working here. Let me just make sure the tablet's working.
Ooh, jelly. We're gonna do a worksheet now?
No, we're still taking notes. It's just that my computer is.
Can we turn in the warm-ups to you?
No. Never. Warm-ups your notes.
Put your stuff. What time I was born? Who's gonna know that?
Alright,
Are
here
we
we go.
supposed to know that?
Yes.
Where's? The exact time.
My rising is, my moon.
What the hell is a rising?
We're talking about star signs.
Rising, and then your,
They're like, sorry, we're not gonna have it.
personality is how you come off.
No, we're not.
It's a pre-workout.
What am I?
And you're a Taurus, I know.
Alright, here we go. Let's go ahead and get started.
Oh, you guys are talking about zodiac signs?
That's what you're finding
Alright,
I'm with Gemini, something like that.
so
Is that what it's called? Isn't that bad or is that good?
alright, let's pay attention right here. So like I said before, you would take the second number. Alright, pay attention right here. A sub 2 divided by A1.
And then second above the.
Yeah, second above the first. Alright, next. Alright, let's pay attention right here. Yes. Hold on, because Cameron needs to go first. Cameron, hurry up, let's go. Somebody's waiting.
Oh, I'm in Aries.
Hurry up, Cameron.
Alright, so let's look at this sequence here.
You better hurry up.
We're looking for this sequence here. Alright, so the sequence is 4, 18, 16, 32, and 64. So what I'm going to do is I'm going to look at the, put this in terms, right? And we're going to multiply each time by what?
By 2.
By 2. Alright, each one gets multiplied by 2. Alright, if you want to write this down, you can write this down. But I'm going to move on here in a little bit. So I'm multiplying each one by 2. Now, again, I could have easily taken the second number, which is 8, divided by 4. 8 divided by 4. What's 8 divided by 4?
2.
2. So that's where I get my 2. But in order for this to be a geometric sequence, it has to have a common multiplier. So it has to be multiplied by 2 each time. Again, I cannot multiply by 3 like after the second number or by any other number. After the second term, it has to be the same all the way across. Alright? Any questions there? Questions there? Alright, next one. So ready? Next one are going to be some examples.
So it's basically just like what's the answer to the division problem?
Basically, yeah. Alright, ready? Ready? So I'm just multiplying by 2 each time. Alright, so let's look at this one, like we did last class. We're looking for the first term and then the common ratio. The first term and the common ratio. Alright, so Elijah, what's the first term in the sequence 2, 8, 32, 128, 512? Elijah D.
Yeah.
Number 1, what's the first term?
4.
The first term for, I'm on the next slide. It's a second delay. So what's the first term?
First term.
What's the first number?
Oh, 2.
2. Alright, so 2 is the first term. Alright, what is the ratio? The ratio, now the ratio is 4.
Yeah.
4 is what I'm multiplying by. Alright, multiplying by 4. I multiply by 4 to get the next number. Alright, and again, if you don't know, take the second number, which is 8 divided by 2. Alright, question? So I'm multiplying by 4 each time. Multiplying by 4 each time. Alright, Tyler, put it away. Alright, next one. Alright, here's the second one. Alright, let's see who we're gonna call. Brittany, what's the first term?
225.
Alright, first term is 225. The first number of the sequence is 225. Alright, now here's going to be a little challenging one. It's going to be somewhat of a challenge. What is the ratio?
Times 5, or the ratio?
Yeah.
45 over 9?
45 over 9, which is
5.
5. Well, actually, it's the other way around. It's 9 over 45. Go ahead.
Oh.
9 over 45. Or you could say 45 over 225, but it's the same ratio. Alright, which is 1/5. Alright, 1/5. Alright, let's pay attention on here because I want to make this quick note. Quick note here. Alright, so you take the second term, which is 45, you divide it by the first term, which is 225. If you haven't done this already, or you haven't used Decimal Scientific, I would get used to it because you're going to rely on it quite a bit this semester. Alright, challenge. I'll see. Alright, so 45 over 225. Alright, when you plug that in, alright, you get 0.2. On Decimal Scientific, just to the right of your decimal answer, there's a fraction key. If you click on that, it'll give you the fraction, which is 1/5. Alright, so the 1/5. Now, what is 1/5?
9?
1/5 means this. I'm dividing by 5. I'm dividing by 5 each time. Right? 225 divided by 5 is 45. 45 divided by 5 is 9.
Can you go like, this is what I did in the syllabus. So like I saw the 9 and the 45.
Yeah.
And like obviously I thought it was like being,
Yeah.
like they're gonna go up, right?
Yes.
So I found out like what 9 is to equal 45 but multiplication. So obviously 5.
Yes.
Can you do that?
Yes. Alright. Alright, listen up over here. Alright, so Talon had a question if he can use any two numbers. Right? He saw a pattern which is 45 and 9. He knows that he had to multiply 5 to 9 to get 45. You can use any two numbers here, but you have to make sure that you understand if you're increasing, you're going to have a whole number or integer. If you're decreasing, you're going to have a fraction. Here I'm decreasing, so I should have a fraction or a decimal. Right? My fraction is 1/5. Now, you do have to remember that it has to be a common number. So if I use that 5, then I have to divide by 5 here, divide by 5 here, and I should get that same answer as I move along. Alright, next one. Alright, and again, this I just finished saying, you gotta make sure, double check. Alright, let's do the next 3. If you don't have a calculator, I would have a calculator ready on your Chromebook, not your cell phone, it's your Chromebook. Alright, we're gonna fill in the next 3. Alright, here we go. Next 3. Alright, so it goes 1, 2, 4, 8. What's the next number?
16.
16. After 16 is what?
32.
32. After 32 is?
64.
Alright, how did you get 16, 32, and 64?
Multiplying the 2.
Multiplied by 2, correct. So your common ratio is 2. I'm multiplying by 2 each time. Remember, arithmetic sequence, we're adding. Here we're multiplying. Alright, here's a little challenge to you here. I go from positive, negative, negative. I go from 5 to negative 15, negative 15 to 45, negative 40, or positive 45 to negative 135. What is the common ratio here? What am I multiplying here? What am I multiplying by?
By 2. Negative 3.
Negative 3. I'm multiplying by negative 3 each time.
Oh,
So it's negative 3 each
Why
time.
would it go back to 45?
What?
Why would it go back to,
So 5 times 3 is 15. 15 times 3 is 45. 45
Yeah.
times 3 is 135.
because it's
So-
negative and negative.
Yeah.
Yeah.
So it goes positive, negative. So this middle answer should be a negative. All right. So what is 135 times 3? 135 times 3. Somebody.
405.
405. What's 405 times 3? And it should be a negative 3, but negative what?
1,215.
1215. All right. So 1215. And then what is 1,215 times 3?
Oh wait, no, that's not right. 1,215 times 3 is 3,645.
3645. All right. So there it is. All right. So what I'm doing, if you don't know this, you use a calculator, but you're just multiplying by 3 each time. 405 times a negative 3. Negative 1215 times a negative 3. All right. 3,645 times a negative 3.
Are we gonna have
What?
are we gonna have like an assignment like this?
A silent what?
Assignment.
Yeah, we'll have an assignment.
Is that a 9 or a 4?
640.
30, what? 36,045?
10,000.
Alright, yeah, we don't have to go, we stop there. Alright, here's the next one, the next sequence. I go from 4,000 to 2,000, 2,000 to 1,000, 1,000 to 500.
Subtract 2,000.
Alright, so,
Or no wait.
we're not subtracting because we're
Yeah.
multiplying.
0.
So,
Times 2,000?
we're
Negative
you
2,000.
can say you're dividing, yes,
5.5.
and you're multiplying by 0.5 or 1/2, right? So you're dividing by 2, or you can say you're multiplying by 0.5 by 1/2. Alright, so you're multiplying by 1/2,
250.
so 250 is the next number. After 250 is what? What's
125.
125? What's half of 125?
50
62.5.
62.5. Now,
No, he's really smart, so he doesn't need to focus on it.
I'll put it up there, there it is. Alright, so it goes 4,000, 2,000, 1,000, 500, 250, 125, and then you put 125 over 2 or 62.5, whichever one you want to use. And again, if you use Desmos and you want to keep the fraction right off to the side of the answer, is the fraction key, which is a little circle with the little fraction. Alright, any questions? Any questions? Alright, so as far as the objective goes, we define what a geometric sequence, we know what it is or not. Common ratio, that's with the multiplier. We did the next 3. Next thing is the explicit formula or the equation. Yes, what?
What was the last one again? Like,
The 62.5?
no, wait.
So I'm dividing by 2 each time.
Oh, okay.
Or you can say I'm multiplying by 1/2. So multiplying by 1/2 or dividing by 2.
Okay. Thank you.
Yeah. Alright, the last one, the explicit formula. Alright, so this one is very similar to the arithmetic one. For those of you who are absent, you're going to see some, when you go back and look at the notes, you're going to see that the slides are very similar to each other. One is you're adding, this one you're multiplying. Alright? So let's look at this sequence. We have a sequence 2, 8, 32, 128. To make this formula, or to make this equation, what I'm going to do is I'm going to take the first term, a sub 1, and I'll put it in for a sub 1. Then I need the common ratio, and I'll plug that in for r. And then the rest is just going to remain the same, which is a sub n, which is the solution for a specific term. And then n is just that specific term. Alright, today we're not going to calculate for a specific term. All we're doing today is just setting up. Alright, so to set this up, I'm gonna take the first term, well, let me just write down, a sub n is equal to the first term, which is 2, times the ratio, what is it multiplying by each time? I go from 2 to 8, 8 to 32, 32 to 128. By 4, right, this is the first example. By 4, and then n to the negative 1 at the top. Alright, now, do you have to put parentheses? For scientific calculators, I would just do a habit of putting parentheses up here. If your 4 is a negative 4, then put a parentheses around your base to be from being a positive 4 to a negative 4. You need parentheses around it. Only if it's negative. Alright, are there any questions? Any questions? These are the notes. We're going to do some problems from the assignment.
How much questions are on the side?
The assignment, same, 18.
18?
Yep. Alright. Any questions? No? Alright, here we go. Let's look at the assignment. Alright, question number 1. Alright, if you need separate paper, you have separate paper?
Oh,
Yes.
how many more answers do you want to? Like, how many more blank spaces do you want?
I already did. Here, open up the worksheet. The worksheet is online Google Classroom. Alright, here we go. When I post these notes, the font will be a bigger font. Right now, my tablet's not working properly. I don't know what it is about this class that everything breaks. Alright, here we go. Ready? Alright, so for the first 4 questions, all you need to do is just determine if it's a geometric sequence, yes or no. That's it. Just a simple yes or no. So looking at question number 1, I go from 2 to negative 12, negative 12 to 72, 72 to negative 432. Is this a geometric sequence? Yes or no? So, Forrest, is this a geometric sequence? Yes or no? Yes.
Yeah.
It is?
Yeah.
Alright, how do I know it is a geometric sequence?
Because if you divide negative 12 by 2, you get what?
You divide by,
Negative.
times it by negative 6.
Alright, you get negative 6. Alright, and that is correct, you get negative 6, but in order for it to be a geometric sequence, I have to make sure that all these, when I multiply, I have to use negative 6 for all these. Forrest, back to your seat. Alright, so if I multiply negative 12 times negative 6, I get 72. If I get multiply 72 times negative 6, I get negative 432. So yes, it is. So it does work out.
We don't have to write the whole problem, just yes.
Yeah, but if you're going to use this as your note, I would write out the whole problem. Alright, so yes, I'm multiplying by negative 6 each time. So it does work. Alright, the second question, question number 2. So this one works. Question number 2. Is this one a geometric sequence?
No,
No. Why do you say no?
because they don't all multiply the same thing.
Alright, so they don't all multiply by the same thing. So I have 23 over 7. It's a decimal, right? It's like 3.1. Alright, 3.1 or 3 point something. And if I take that 3 point something and multiply it each time, do I get a 127, a 623? I don't. So it does not work out. So this is a no. Now, you could hit decimals and use that as a multiplier, but it will be a clean decimal, like a 0.5, a 0.25, right? So I'm dividing by, I'm dividing by like a 2, you divide by 4, divide by 3. All right, any questions there? Any questions? Any questions? Questions. All right, so again, 1 through 4, it's a simple yes or no. 1 through 4 is a yes or no. All right, due to time, because I was trying to fix the laptop, I'm only going to give you about a minute on 3 and 4, so just pick one, answer it, and I'm going to move on to 5.
3. No.
No, you're going to answer on your own. You answer on your own. It's going to be a yes or a no. And there's a 1 yes and 1 no, so you just got to determine which one's which. Again, the assignment is on Google Classroom. If you don't have the Google Classroom code, let me know. If you go on Aries, you should be able to pull that up.
This one's a no.
Alright, let me have your attention up here. Alright, 5 through 8. 5 through 8. 5 through 8 is like 1 through 4. You're going to tell me yes or no, but the only difference here is you got to tell me the ratio now. You have to tell me the ratio.
Like the number being multiplied by?
Yeah, but the number that is being multiplied by. Alright, so number 1, is that a yes or a no?
Yes.
Yes. I agree with you, it is yes. What is that number that they're
Negative 6.
No, it's just 6.
Just positive 6.
Six.
Just positive 6. Negative 1 times positive 6 is negative 6. Negative 6 times a positive 6 is negative. The signs don't flip. So if the signs switch, then it's negative. But since they're not switching, it's all negative, all positive, it's going to be that same number. Alright, before I move on, is there anybody that just do not understand what we're doing?
This is easy.
Is there anyone?
Oh, this might
Alright, so all we're doing is just trying to find a number that is being multiplied by. Alright, what times 1 gives you a 6? A negative 6, right? Alright, so it's positive 6 that multiplies to negative 1 gives me a negative 6. What times 6 gives me a 36? 6. What times 36 gives you 216? 6. Since they're all going to be a 6, then it's a common ratio of 6, which is a geometric sequence. All right, how about number 6?
Yeah. Yes.
Yes. All right, it is a yes.
Times negative 3.
And I'm multiplying by,
Negative 3 because it's a positive.
yeah, the positive, negative, positive, right? So it's negative 3. All right, each time I'm multiplying by negative 3.
And 4, are we?
All right, that's what you're doing 5 through 8. All right, continue working. All right, about 30 seconds. Now I'm gonna have to answer 9. That way I know I'll cover each section. Yes, of course.
So, if you get a decimal like 0.33, it's no?
Double check it. 0.33 means you're dividing by 3. So you gotta divide by 3 each time.
Okay.
So it could be, we just gotta double check. So you divide by 3 each time. Alright, here we go. Next one, number 9, 10, 11, or no.
Hey,
What
what
number
number?
Oh,
6?
yeah.
I want 5 and 6.
What?
What
5 and
is
6,
number
y'all do.
six?
I'm not gonna do all the
Six,
problems.
negative 3.
Negative 3?
I'm not doing all the problems for you. You gotta do some of them on your own. Come on. Alright. 9. Alright, number 9. Number 9 is one where you find the next 3. Actually, 9 through 12, you find the next 3. Here, I'm not tricking you. They're all geometric sequence. You just gotta go out and find the next 3. Alright, so what is the multiplier?
Negative 2.
Negative 2. I'm multiplying by negative 2 each time. Right? Because it's a positive, negative, positive, negative. Alright? So negative 2 each time. So what is 16 times negative 2?
Negative 3.
Negative 32. What's negative 32 times negative 2? 64. All right, 64 times negative 2, negative 128. How did I get that? Just by multiplying the previous number, 16 times negative 2.
You want us to underline that?
You could. That's how I got negative 32. Take my negative 32 and times by negative 2, positive 64. Alright, we are going to use a calculator quite a bit in this class, in this second semester. So if you're using it, you're not showing your work, it's just going to be a yes, it's correct, or no, it's not correct. So make sure that if you show your work, at least you get partial credit. If you don't, make sure you're 100%. Alright, positive 64 times negative 2. And you get your negative 128. Don't worry, before I post these notes, it's going to look a lot better. Alright, and that's all you do for 10, 11, and 12. Find the next three numbers. Alright, the last one. Alright, the last section. Alright, before you put up, do not put up because you're going to need to know how to do this last section. Alright, number 13. Number 13. So stop where you're at. Let's look at number 13. Alright, so for number 13, you're just going to set up the explicit equation. So you're going to use this formula. A sub n is equal to A sub 1 times R raised to the n minus 1. Alright, A sub n, so we're solving, but we're not solving for anything, all we're doing is just setting up, is equal to the first term. What is the first term of this sequence?
Negative 4.
Negative 4. Negative 4 times the common ratio. What is the common ratio? What's the multiplier?
Negative
5. It's just going to be 5 myself, because they're all negatives. So 5, and then n minus 1 is my exponent. And that's it. That's all I'm doing. Alright? I'm multiplying by 5. Alright, before you put up, I'm going to do one more with a negative multiplier, and then we're done. Alright, this is number 13. Alright, I'm going to do the next one. Alright, number 14. Number 14, really fast, and then you can put up. Alright, number 14. A sub n is equal to the first number. What's the first term of the sequence? 3. Alright, what is the multiplier?
Negative 5.
Negative 5. Alright, when I use a negative as my base on an exponent, I'm going to go ahead and put parentheses. Just make that habit. Negative 5 in parentheses. And then n minus 1 also in parentheses. This is my exponent. And that's it. Alright, and when we use the calculator, I can tell you when to use parentheses and when not to use parentheses.
Excellent.
Alright, just remain on your desk, remain your seat.
Hey, question. Are you gonna look at it tomorrow?
No, we're going to turn this in. We are going to turn it in tomorrow. So you going to work? We'll do a few
Did you
tomorrow.
finish the ultimate?
No, hold on. But try it.
No. What do we do?
Sylvan,
That'll be a lot of
do today.
Alright, if you need help to supply lunch today or tutoring,
Yeah,
alright, stay in the classroom, not leave until the bell rings.
my class.
No, you take another stuff.
I leave now.
Until like on Wednesday last week.
So I'm afraid to ask you, do you leave like a few minutes early? Does that help? You have to deal with the traffic.
Are you going to practice
I
today?
can let you go like a few minutes early, so you don't have to deal with it.
Alright.
He's a cheater.
See you
I'm
first.
a dog. His main one is a dog.
I need that key.
Okay, I'll be right here. Were you intended to watch the video? No? Okay. Not that hard.
So I went to finish my homework there.
Yeah. Set out here. Oh, by the way, if you grab your warm-ups, the warm-ups are here in front of the class. It's on the printer. On the printer, your warm-ups.
I know, guys.
Wait, did you have to grab a paper?
Yeah, the only handshake. Sir.
Chromebook. All right, go ahead and get started on the warm-up. The warm-up's to the front of the class. Yes. Yeah, you could. I forgot what I gave you. I think I gave you like the extra credit points. Talk to me during lunch, because if you do your final, it's not like you're gonna move it up a whole lot. You would have to get like near 100, to move up. And I think I gave you the next letter grade. But whatever was going into the final, whatever you needed to turn in, you can turn in. You can change it, but I have to look at your grade. I don't know what it is. Are your warm-ups there? Got it?
Yes, thank you.
All right, let me get the attendance. By the way, if you have your arithmetic sequence assignment, I'm going to collect that. You should be at the last table. Alright, let me see who's missing. Everyone's here. Number 7. Who's 7 again? Isaac. Adam, who's this next to you? Fernandez?
Oh, yeah.
Yeah. And who sits in front of you? Who?
Gabe.
Savannah? Yeah, Henry Where's Evie? Everardo? Alright, Everardo, you sit, number 16 now. Number 16. Just right in front of Henry. Rosales. Here. Leo's not here. Marlon's not here. I think that's everybody else. Here. Alright. Let me just plug this into the online and then we'll get started. Alright, I'll be collecting the arithmetic sequence assignments, so have that ready to go. And we'll begin. Give me a quick minute, I'm missing somebody here. There it is. Alright, here we go. Let's begin. Sixth grade. Alright, again, for those of you who were out last week, anytime last week, what I'm starting to do now is post the assignment on or the notes on YouTube. So if you're ever out, you can just go on YouTube. You can watch it live. And so you don't fall behind. And just try to keep up with us. Alright, if you have any questions, you can always email me. And I can answer your question. And we can set up a Zoom. Whatever the case may be, we'll try to figure something out to help you stay along with the class, fall too behind. You don't feel overwhelmed because you missed so many days of school. Alright? Last week we didn't really cover much. We had 2 foggy days and then 2 other days we used for benchmark. So there was only 1 day that we used for instruction, which was Thursday, and we talked about arithmetic sequence. Arithmetic sequence is a sequence, or a sequence is basically a list of numbers that have a specific order. Alright? And there it is. And what we're looking at is from that list of numbers, am I adding or subtracting, right? So if I'm adding a number, an integer, to increase, or am I adding a negative integer to decrease, alright? So that was arithmetic sequence, and they had a common difference, and I added that same number each time. Alright? And that's what we have, that's what we did on Thursday in the assignments we post on Classroom. You can do it on paper and submit the paper tomorrow for those of you who are absent, or you just upload it online. It's not a hard assignment, but is an assignment that, that you do have to look at some notes and maybe a video or two to kind of get it. All right, at this time, do you have any, raise your hand, I'll come by and pick up your assignment if you want to turn it in. The paper copy, if not, you upload it online. Anybody over here? Over there? 5 of you turned it in Thursday before we left. Some of you uploaded online. Others did not. So I'm just kind of around checking. Anybody else? Alright, I'll put these grades later today, probably during lunch. So make sure that you have it taken care of. Yes,
I just have to do the last one.
that's fine. You turn in before you leave.
Okay.
Alright, now let's get into the geometric, the new assignment, the geometric sequence. The geometric sequence. Alright, so here we go, geometric sequence. Alright, so again, very similar to the arithmetic sequence. What we're going to be doing is we're going to determine or identify a geometric sequence. We're going to look at a sequence and determine is this geometric or not. We're going to identify the first term, the common ratio. So instead of the common difference, here's the common ratio. And then we're going to identify the next 3 terms in the sequence, and then finally we'll end the class with write an explicit equation, right? So end the class with write an explicit equation. All right, anyone still writing objectives? You don't have to write the objectives down, just kind of what we're doing for today. If not, it's on the whiteboard, you can write this down. All right, let's look at the warm-up. So the warm-up is very similar to the warm-up we had on Thursday. You're given some patterns, some figures, and you're just trying to figure out what comes up next, what's next. All right, so the first one, I have a square or a tile, if you want to call it a tile, and then the next one is another square, but it's with 4 tiles. And then the next one is another square, but with, a rectangle, one else a square, with 16 tiles. Alright, so the square is getting larger. Alright, now if I were to continue this pattern, what would be the next term in this sequence here? What would be next? You can tell me how many squares or how
64.
Alright, 64, right? And if you were to draw this out, how would it look? How would it look? How many tiles is the length and how many tiles is the width? You're correct. It is 64. 8 and 8. Alright, 8 and 8. And 8 by 8. Alright. So you're correct. So you have 8 going up and down, and then 8 left to right. Alright. Now, for those of you who did not draw and you got a number, how did you come up with that number? How did you get 64?
Multiplying by 2 for each.
Alright, you're multiplying by something, alright? So I'm doubling, right? But you're going in 2 different ways, right? Going up and down, and also the other way. So you are multiplying by 2 in 2 ways. So you're multiplying 2 this way and 2 that way, which is, you're squaring it, right? So 2 times 2 is 4, right? So the number of tiles inside, you're going to be increased by a multiple of 4. Right, so I go from 1 to 4, 4 to 16, 16 to 64. So I'm multiplying by 4. Right, and if I drew this, I double it going up and double it going to the right.
So you're multiplying 2 by the x and y.
You're multiplying 2 twice, which is 4. Yeah, so you're doing it twice. Alright, let's look at this one. I have 2 smiley faces, then 6, then 8, 18. Alright, so what would be the next number? How many smiley faces?
54.
54, alright? Did anyone get something different from 54? You are correct, it is 54. Alright, how did you get 54? How did you get 54? Alright, you multiply by 3. So I'm tripling these, right? I'm multiplying by 3. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. Alright, so it increases by a multiple of 3. Alright, next one. Here they look like little figures that represent a person. So you have one person at the very top, followed by 2 people underneath that person, then 4 people underneath that those 2. So if I were to continue with this pattern, the next level underneath would have how many? The next level underneath this would have how many people or figures? Cheyenne, how many figures will be at the bottom level, the very bottom one, if I were to go this, continue this pattern? How many do you think?
6.
6? It's a little bit more, but yeah, it's going up. More than 6. Go ahead, Ethan.
It's 8.
8. So 8, yeah, so it's 8. So each person gets 2. So there's 2, 4, 6, and then there's the 8. Alright, so 8. Alright, good. So I'm just double. Each person gets, has 2 people underneath them. Alright, any questions there? Any questions? No? Alright, let's get to the notes. Alright, so the notes are going to be very similar to the arithmetic sequence notes. Alright, so I'm going to go ahead and just put this out there so that way you have it. Alright, so the notes again, very similar to arithmetic. Arithmetic we added, right, or in some cases we subtracted if it was a negative integer. Geometric sequence is there, you're going to see the terms are either going to be increasing or decreasing, but they're going to be increasing and decreasing at a different rate. Alright? So what we're doing is this. A geometric sequence is a sequence in which a ratio, R, can be multiplied to each term to get the next term. Alright? So what we're doing here is we're multiplying. We're multiplying. We're multiplying by a certain number. Alright, so a sequence in which the ratio can be multiplied to each term to get the next number, right, next term. Alright, that's a geometric sequence. So the difference between arithmetic and geometric, one is multiplying, the other one is adding. Alright, the R is called a common ratio. So that ratio, that number between the two, the ratio between one number and another number, has to be common in order for it to be a geometric. Alright, by the way, write these down as part of your notes if you need it. Also, you'll keep it separate with, from your assignment. Alright, so again, geometric sequence. So it's going to be, again, similar to arithmetic, but we're doing a different type of operation. For geometric, we're going to be multiplying. Right? It's a sequence in which a ratio, R, can be multiplied to each term to get the next term. That ratio, R, is called common ratio. Alright, to find the common ratio, you'll divide any two terms, right? Or two terms from the one that follows. Alright. So the way you do this is, I'll just give you the formula here, is you're going to take gonna take is your second term, and you're gonna multiply it by your first term. Second term multiplied by the first term. Picking up, let's see what's going on over here. It's not picking up right here, let me just write it. Keep that. So A sub 2 divided by A sub 1. Alright, A2 divided by A sub 1, which is basically the second number, the second term divided by the first term. And really, it's any two numbers, but you put the second one, or the one that follows, divided by the previous one, the one before it. So the second divided by the first. All right, any questions? Any questions to this point? All right, so these are just basic notes. We're gonna do now some examples so you can have in your notes, and then we'll jump into the assignment. All right, let's look at an example here. To find the common ratio, I'll look at a sequence, right? You have the first term, the second term, the third, fourth, fifth, right? 4, 8, 16, 32, 64. To find the common ratio, you have to determine what number is being multiplied each time. What number is being multiplied each time? I multiply each number by 2. 4 times 2 gives me 8. 8 times 2, 16. 16 times 2, 32. 32, double that, you get 64. Alright? Each time, I'm multiplying by 2, and it continues with that pattern. Alright? Any questions? Any questions? In order for it to be a geometric sequence, it has to have a common ratio. In this case, it does. Common ratio means it's multiplied by the same number all the way across. Alright? So let's look at some other examples where you find it. Anyone still writing? Anyone need more time? All right, go ahead. And again, if you don't want to test every single, well, you're gonna have to test every single one of them out, but just a reminder that there is a formula, which is the second number divided by the first. 8 divided by 4, which is 2. Alright, ready? Alright, so let's look at an example, another set of numbers. Alright, so number 1, the rate of the sequence goes 2, 8, 32, 128, 128, 512. Alright, so what's the first term in the first example? What's that first term? What is the first term? 2. First term is 2. That's the first number in the sequence. What is the common ratio? What number do they have in common that's being multiplied by? By what? By what? Alright, let's look at the formula. So we take the second term divided by the first term. The second term is 8 divided by the first is 2. 8 divided by 2 is 4. Alright? So I'm multiplying by 4 each time. I'm multiplying by 4 each time. Alright, let's look at question 2, or example 2. Alright, example 2, I start off with 225, 45, 9, 9/5, 9/25. Alright, the first term for the second sequence is what? What's the first term? First term is what? 225. Alright, 225. Alright, now to determine the common ratio. Can someone tell me what's the common ratio? Or tell me how to set it up at least. Alright, so I heard what? 45 what? Alright, so 45 over 225. 45 over 225. Alright, so 1/5. Alright, so what I want you to get used to doing is using a calculator, using Desmos Scientific. So if I plug 45 over 225, if I plug this into the calculator, my answer is going to be 0.2. Right? Just to the right of the 0.2, your solution is a fraction key. If you click on it, it'll convert it back to a fraction. So it'll change it back to 1/5. Alright? So the ratio, you write 0.2 if you want, or you could write, or 0.2, or you could just write 1/5. Whichever one you want to do it's fine with me. Alright, so 1/5 or 0.2 is the ratio. 1/5 means I'm dividing by 5 each time. 225 divided by 5 is 45. 45 divided by 5 is 9. Alright? Now, in my last class, the student had asked me, like, can I just look at different numbers? Do I have to use the first and second term? Or can I use the second and third term? You can use whichever two numbers. Right? What they did was to take 45 and 9. They know that there was a difference of 5. Right? Well, not a difference, but I multiplied by 5. 9 times 5 is 45. So then they just stated it backwards for the opposite, which is divide by 5. So it is decreasing, so I'm dividing by 5. Alright? But you do have to know that when I'm plugging this up and saying the equation, because the standard is that you have to build a function out of it. So you have to understand that I'm multiplying, that I need to multiply. So I need to use the 1/5 or 0.2. I cannot put divided by 5. Alright, any questions there? I think I gave enough time to write those two down. Alright, and again, it's very similar to arithmetic. So you haven't missed much. It's just geometric. Instead of adding, we're multiplying. Same concept. And again, just a reminder, always check all the numbers to make sure that it is common all throughout. Alright, the next part of it, or the next objective is to determine the next 3. To determine the next 3. Alright, my pen's not working, so I'm not going to be able to write that one. Just like write it using my keypad. Alright, so I go from 1, 2, 4 to 8. What would be the next number?
16.
16. After 16 would be what? 32. After 32, it's 64. Okay, how did you get 16, 32, and 64?
Multiply by 2.
Multiplied by 2, right? That's my common ratios multiplied by 2. Alright, good. Alright, the next one. Now it goes from positive to negative, positive to negative. 5, negative 15, negative 15 to 45, positive 45 to negative 135. What is the common ratio here? So again, if you want to use these first two numbers, what's that? What am I multiplying by? By positive or negative? Alright, negative 3. Anytime you go by a negative, you're going to have that switch from positive to negative, positive to negative. Alright, so negative 135, the next answer should be a positive. It's going to be a positive what? 405. Alright, 405 times negative 3. What's 405 times a negative 3? 1215. And then what's 1215 times a negative 3? You'll get a positive answer, positive 3,645. Alright. And you just, all you're doing is just multiplying by 3 each time. Any questions there? Negative 3, sorry, multiplying by negative 3 each time. So again, if you have a switch between a positive, negative, then my common ratio is going to be a negative number. If you do not have a switch, they're all positive or they're all negative, then your common ratio is going to be a positive number. Right? You're going to notice that on the assignment, you're going to have -1, -6, -12, whatever the case may be, but they're all negative. All right, the last example, I go from 4,000 to 2,000, 2,000 to 1, 1 to 5. All right, if I continue with this pattern, what would be the next number? 250, I'm decreasing. After 250 is what? 125. All right, now to get 250 and 125, what did you do? All right, you divided by what? By 2. I divided by 2. All right, so what I did was I took half. I took half of 4,000 and became 2,000. Half of 2,000 is 1,000. All right, so you divide by 2 or you multiply by 1/2. All right, and again, I need that 1/2 for my equation, so I'm going to say 0.5 or 1/2. All right, and then your last one, if you want to leave it in a decimal, you can. Whichever rational number you want to leave, fraction, decimal, it's up to you. 125 over 2 or 62.5. It's up to you. All right. So we checked off the geometric sequence, we checked off the common ratio, and the next few terms. So the last objective is to write an explicit formula. All right. Write an explicit formula. All right, you ready for this? Yes, no, maybe so. All right, here we go. The explicit formula is very similar to the arithmetics formula. The only difference is we're not adding, we're going to be multiplying. And then here we have an exponent. Instead of, the parentheses being right next to the D, here we have an exponent. All right, so we're still using the first term, a sub 1. Where instead of having a difference, you're having a common ratio, R. All right, to find the solution or the solution for this a sub n, this is the solution for a specific term. Right? N is that specific number or specific term that we're looking at. Or it's a specific number is the term. So if I say the 100th term, then I want to find the 100th term. So I just put 100 here. Minus 1 is 99. All right, so let's write this out. Let's see if I can write it big enough here. So in order, and again, we're just setting this up. So in order to find the answer, I take the first term. The first term is what? What's the first term of that sequence? 2, 8, 32, 128. 2. So 2 times R. What is R? What's the multiply? 4. I'm multiplying by 4. Now, we did it this way. I should have done this in the last class, and I'll just do it this way. I'll just go ahead and put parentheses 4. Instead of putting a dot 4, put parentheses 4. You're just getting a habit of just putting parentheses. Because if positive or negative, it's going to be right. So 4, and then raise to the power n minus 1 And when we get to the assignment, you don't have to write n minus one. Let's just say we're trying to find the 10th term. If I'm trying to find the 10th term, I don't have to type in 10 minus 1. What is 10 minus 1? It's just 9, so I just type in 9. Right? But we'll worry about that tomorrow. Alright, so there it is. So 2 times 4, 4 is in parentheses, and then raised to the n minus 1. And that's it. That's the equation for an explicit. Any questions? Yes.
What's the n minus 1 for?
That's just saying the previous number. So remember the equation is, where the definition states that in order for it to be a geometric sequence, you multiply a number by, to find the next one. To find the next one, I need the previous number. So n minus 1 is the previous number. So if I try to find the 100th term, I take 100 minus 1, so I take the last number, which is 99. 99, and I multiply it by 2. Alright, I multiply it by something. So n minus 1 is just the previous number, is the last number. Alright, any questions? Nope. Alright, let's look at some, the assignment. Alright, the assignment's on Google Classroom. The ClassWorks is the geometric sequence assignment. Let me take this off. It's a geometric sequence assignment. Yes. Sure. Alright, if you need paper, there's paper on top of the, I'll get some on top of the printer. What's up?
Oh, I just came to say hi. Or just, came to look.
Yeah,
To
you
see what
can warm up.
everybody's doing. Yes.
And we're live on YouTube. You didn't have to go, you just gone on YouTube. Oh, I didn't send you the link, never mind. It's a different link.
Well, I follow you, so.
Oh, yeah. Well, it's public, yeah, and then it becomes unlisted after a while. Alright, so, keep your papers separate from your assignments separate from your notes. Alright, you ready? Alright, questions 1 through 4, all you're gonna tell me yes or no, that's it, just a simple yes or no. If this is a geometric sequence, that's it, right? We're not gonna focus on arithmetic today, just geometric. Is this a geometric sequence? Alright, yes or no? Alright, so number 1. I go from 2 to negative 12 to 72, 72 to negative 432. Alright, let's see. Gavin, the first one. What do you think? Is this an geometric sequence? Is this a geometric sequence? 2 to negative 12 to 72, 72 to 432.
Yes.
Yes. Does anyone disagree? Anybody disagree with Gavin? No? Everyone agrees? Alright, so if everyone agrees, then what? What is the common ratio if everybody agrees? Is what? Negative 6? You're right, it is. Alright, the common ratio means that what's that number I'm multiplying to each term by? I'm multiplying each term by negative 6. If I did that and using Decimal Scientific, you're going to get the same numbers. 2 times negative 6, negative 12. Negative 12 times negative 6 is 72. 72 times negative 6, negative 432, right? You're switching from positive to negative.
So the negative 6 would be our slope, right?
Yeah, so negative 6 is your ratio. Alright, let's look at the next one. Negative 7, positive 23. Negative 127, positive 623. What do you think?
No.
No? Does anyone say yes? Alright, this is not a geometric sequence. Now, just because you get a fraction or a decimal doesn't mean it's an automatic no. But you want to test these out, right? I'm going to take the second term, and divide it by the first term. So 23 divided by negative 7. Alright, and I'll get some decimal, right, 3.1, 3.2. Take that number and see if 23 times 3 point whatever, you'll get 127, right? 127 times 3 point, negative 3.2 should get you 623. There, I know it's not going to be, that's not it. So yes, it is a no, but you want to double check. Make sure, it doesn't work all the way. It doesn't work all throughout the sequence. All right, any questions there? Questions? All right, 3 and 4 are yours. Same thing, yes or no. Give you a hint. One's a yes, one's a no. You just have to figure out which one's which. Just keep you can talk to your neighbor, just don't shut off the answers. So I'll leave that up to you. So, yes, no, maybe so. Actually, just a yes or no, that's it. Yes, it's geometric, no, it's not geometric. Go ahead and answer those.
He's got a different name on his calendar.
Who? Does he? For what time?
Thursday.
Huh?
Thursday.
This Thursday? Louisiana. Louisiana. Oh, yeah. No, he switched it for the following Thursday. So, yeah, he has that kind of for next Thursday. I need an email. Miss Udali, let me tell her. Yeah, you put me down for next Thursday.
All right. So I just dropped by. I'm gonna drop by.
Yeah, I'm trying to figure out
If you don't mind.
I'm just trying to figure out which activity to do for next Thursday. Because I was thinking of doing something like COVID related.
Mhm.
So I try to figure out following Thursday.
Yeah, I don't know what I'm doing either. And I don't know when it's going to
I'll have something.
But I wanted to stop by some hikes.
Yeah, that's it.
I'm gonna do this every day until we have it so that way they get used to it. So it's
Yeah.
not- I'm just
Go
not
for
having-
it.
you
Doesn't
don't want
matter.
it.
Doesn't matter.
You want the
It's not
exact
good.
one? No. Okay.
Stop by whenever.
What do you want?
Does everyone know Miss Nelson?
Yes.
My favorite.
Thank you.
So Miss Nelson's a math teacher upstairs. Teaches us
Directly above you guys, so you guys are very fortunate. You don't hear when I'm moving tests around. Yeah.
Yeah, so you have to
So what's the?
hear the stuff. Actually, it's the class next week.
Oh, well, that, yeah.
Are you actually moving up there?
What?
Are you gonna move next to it?
No, it's just, they're doing some construction up there, so.
It's a teeny tiny, yes, you have to walk upstairs. I have to walk up and down and up and down and up and down. I've been trying to convince them to put in a fire pole. Wouldn't that be cool? Just drill a hole up here somewhere and then I can just take the fire pole down?
Slide down.
How'd you get?
Maybe I'll never leave. You'd be stuck with me forever.
Oh, no.
I know, that's scary.
Yeah. Alright, next set. Alright, let's see. Next set, 5 through 6 or 5 through 8, same thing. There's only one no though. Same thing, but the only difference here compared to the last time is you have to state the common ratio. So you gotta tell me yes. If yes, what's the common ratio? Alright, so here we go. Question number 5. I go from -1 to -6, -36, to -216. Is this a geometric sequence? Yes, it is. What is the common ratio? So this is the yes, and it is what? 6, right? Multiplying by 6. And it's +6. So my ratio, and I just put it down here, r lowercase r is equal to 6. Sorry, I don't know what's going on with my tablet, it's not working today. Alright, let's look at the next one. I go from full positive or negative to positive, right? So I go from -4 to +12, +12 to -36, 36 to 108, -36 to 108. What is this a geometric sequence, yes or no? Yes, it is. And what is the r? -3 is the r, so -3. And again, the -3 has to be for each one, and it is for each one. So -3 all the way across. Did you forget something?
Paper.
You want to take a whole ring, there's one on the top shelf there, r equals -3.
I've been stealing it from, Tanya.
Oh, yeah, there it is. I'll get another one. Alright, -3 is the r.
Do we have to write down r equals?
Yes, for 5 through 8 you do. 1 through 4 you do not. 5 through 8, yes. Alright, 7 and 8, one of them is not a geometric sequence. You just gotta tell me which one is not. Yes.
The first 4 items, do we just say yes or no?
Yep, that's it. And then the next 4 is yes, no, along with r equals. I'm gonna walk around and if you have any questions, you just stop me. Questions? Are there any questions? Yes. Yeah. Alright, so it goes from what to what? It goes from -3 to -1, and then -1 to 2, 2 to 6. Yeah, it is not, it's not geometric. So no, you don't have to find R. Yeah. So if it's not, then it's a non-common number. Yeah. Alright, so for, again, if it's not a geometric sequence, then you cannot find a common ratio. So you have to find R. Alright, any questions? Any questions? No. No? Alright, let's move to the next set. The next set of problems is just finding the next 3. Now here, I didn't trick you or do anything. They're all geometric sequences, and what you have to do is just find the next 3. Alright, all you have to do is find the next 3. Alright, so I go from -2 to +4, +4 to -8, -8 to 16. I just needed the next 3 numbers. What are the next 3 numbers? What are the next 3 numbers? Alright, so -32, +64, and then negative what?
128.
128. -128. Alright, there it is, -32, +64, -128. Now, how do I get these numbers? I multiply by what? What's my multiplier?
-2.
-2, so I take 16 times -2. Alright, and that's where I get my -32. Then I just take my -32 times -2. Again, you use Desmos, you don't have to do this, use Desmos. The only thing is, this year, or this semester, we're gonna be relying on the calculator quite a bit. So if you do not show your work, you still get credit because we're using a calculator, but it's either gonna be right or wrong. Alright, so make sure that you have it right, you typed everything in right into the calculator, because it's not the calculator that makes the mistake, it's the operator, the person that's doing the typing. So it's operator error. Alright, next one. Number 10. Alright, so I go from 3 to -6 to positive 12 to negative 24. What is that multiplier, and then what's the next 3? What's the next 3? Someone tell me the next 3?
48,
48,
-96,
negative 96,
and 192.
and 192. Alright, just make sure that you continue the pattern for going from positive, negative, so positive 192. Alright, when I post these on the notes later, you can read these, the numbers a little better, 'cause I don't know what's going on my tablet. Alright, let's do number 11 and 12 again. There's no, I'm not trying to trick you or anything, just finding the next 3. They're both geometric. So let me give about a minute to do 11 and 12. Again, Decimal Scientific is, I recommend that, Decimal Scientific. Alright, number 13. Are you ready for 13? Alright, number 13, all you're doing, again, is just setting up the equation, 13 through 18, setting up the equation. You have to make sure it's a geometric sequence, first of all, and then you set up the equation, the explicit formula, or the explicit equation. Alright, so in order to do that, you need the formula, so let me write this big. A sub n is equal to A sub 1, which is the first term, times R, and then n minus 1. Now I'm going to use parentheses for the R and for the n, just so that if we ever come across a negative number, negative R, and we're typing this into the calculator, we're not getting a wrong answer, all right? So we want to make sure that we're doing this correctly and typing in to the calculator. So the calculator reads it as the first number times, if I just put negative without the parentheses, so the negative 1 times R could be like 2, negative 1 times 2, but 2 is going to be the exponent, or the base to an exponent, so it's going to give you a negative number when it could be positive. Alright, so here we go. Ready? Again, we're not solving for anything today, so we're going to just setting up. So A sub n is, here's the solution is going to be based off of this setup. Now I'm going to take the first term. What is the first term of this sequence? Negative 4, so I'm going to put negative 4 here. Times negative what? Or what? 6? Alright, so let's double check. 4 to 20, how many times? 4 to 20? 5. So it's actually going to be 5 times. Alright, so 5. It's going to be positive 5 because the signs do not change, they're all negative. So each time is 5. So I'm going to put 5 is my base. Now my exponent is just n minus 1. And like I said, once we get to the calculating, you don't have to right, n minus 1. If I'm solving for the fifth term, it's just 5 minus 1, which is 4. Alright, we're not doing any solving today. Again, we're just setting up, so just leave it alone. Oh, nice.
Sequencing.
Yeah.
So I think airplane, geometric,
Nice. Alright, any questions? Anybody want to see a different number? Another number? Alright, you just look that up. Yeah. If you're finished, I'll get it. Just make sure they're all 18 are complete though. All 18 are done.
Why do you like seeing people on there? Why is it
Now those are keep with your notes. Alright, we'll see you later.
yeah. Thank you, have a good day.
Yeah, thanks, you too. Geometric, today's. Computer, alright, you have a good one. Good day. Go. Been holding this in. Second period. Yeah, 281, 5,000.
5,004.
Yeah.
Okay, thanks, man.
What's up, guys?
I'm gonna get coffee. Can I get back yet?
Yeah. He just walked out to get a coffee. He'll be back about 15, 20 minutes.
I left my phone in there.
Yeah, he just left to get some coffee real quick. He should be back here soon.
Okay.
Yes.
I have a question for you.
Yeah.
How was boys volleyball trying to show you?
It was if one of the 4 people come out.
Really?
Yeah.
They good?
No, alright. They're
I
not
know,
like
I
girls.
don't really know about yet.
They're not like girls. Like girls, you have to like
Yeah.
watch and stuff. But
So, are you gonna have enough to make the team? To make the team?
eventually we will. Right now, it's just like we have to get the word out
Mhm.
and try to get more people to come out.
Yeah.
But I mean, we have.
I think there's so many people to go, but they're always like,
There's a place to sit. They don't know.
that literally, if you watch what actually men's volleyball looks like, you're not thinking.
They don't know. Like once they get into it, like I tell these guys like you gotta try out, you gotta play, because that's the one sport. I'm saying like I'm a coach, but I've been around. I used to be an athletic director. That people wait to talk to you after the game,
Yeah.
exchange contact information.
Yeah, I know.
That's the
All
one
the girls.
sport. Yeah, it's the one sport that you'll have a following.
Yeah.
Look at I don't know if you're familiar with, like, I used to coach Adam Gross.
Yeah, I know him. So my brother, his Dominic Marquez, and
Yeah.
he played volleyball, but I don't know if he's gonna play this year, but yeah, Adam Gross, I've seen him before, and
He
I
did-
don't doubt it.
He went from not knowing the sport and not even being able to pass the ball to like slamming the ball down
Yeah.
to being a halfway decent player. Like he could play for Fresno State if he wanted to.
Yeah, well, I think now I know he plays like club also.
Yeah.
So
Yeah,
it's just a sport that they gotta develop. I didn't know they did.
yeah. And he's when we go play like in San Luis, like he has a group of people waiting for him.
Just waiting for his number.
They already know him because like they follow him on
Oh, TikTok.
TikTok.
Yeah.
So.
Well, good luck.
Yeah, I'll get more people out. It's just yesterday's a holiday, so
Yeah.
we're trying to figure out.
Got it. Have a good day.
Thanks, you too. What's up?
Nothing much. I'm bored and I don't know where to go. So I just decided to myself, I'm just gonna go my first 50.
Let's.
Just about 15 more minutes. About an hour to do it. 15 more minutes.
15.
Can I tell my assignment right now? Or
Attention students,
For what? Geometric?
can we have Luther Gilbert to the front office? Luther
Which one?
Gilbert
The one that's
to the
due
front office.
yesterday, or the one due today, or the one that is
the one due today was the,
due from last week?
yeah.
Yeah. That's fine.
Oh, please have the paper. Yes. I still have the paper. Let's go. There you go. Now Frank called McDonald's. Oh, why would I do that?
6 at a corner.
I called McDonald's and I said, do you have any big chungus in those and the long breadsticks that they have? I saw them on your commercials.
What did it say?
They say, I'm sorry, what? And then I tried convincing them that they had one. But they didn't understand what I was saying, so I just said, oh, this may be the wrong phone number, so and then I just hang up.
Nothing else to do.
Oh, I think that's so loud. It's because I was so bored, like 10 minutes ago, and I just decided to try and calm my tongues.
Did you do unknown number or what?
I just called like a random number. I just typed up McDonald's numbers and then just scrolled down and then I just chose one. Like out of nowhere.
I've seen TikToks where they randomly text.
Like random phone numbers. Like,
Yeah,
just,
random phone numbers.
like they guess like any phone number and they just text them.
Yeah,
So they just like type random numbers like
yeah.
this thing and
They'll
it's
just like they'll play along, or they'll play a joke on like, hey, you're having my kid or something.
you have my kid and all and then one of them was trying to follow up with them. So they just mess around basically.
Yep.
Oh, no, do that.
report to the front office.
Bro,
Dylan.
oh, yes. Oh my God. Lord. These bad boys, you know,
So, yeah, we'll pass them out. Yeah. Turn the page, the numbers are there. They're the first sixth graders. Arithmetic is the homework that's there online. Yep. Yeah. Are you good? So far. Yeah, it's the arithmetic. Yeah. It's not arithmetic, the one that's yeah.
Yeah, Xavier, why don't you laugh like that, bro?
It was you, Xavier?
Yeah, what's this, bro? Boy, stop asking. I got homework. Oh, I got homework in my backpack.
Now you
Put it down.
yeah, you're 15.
Whoa.
No, Xavier, you better not have.
Hey, get it back to your seat, bro. All right.
Alright, let's go ahead and get started. If you do not have a warm up, grab a warm up. I need the food put away. Food put away.
I was driving my dog. Like in that field area. Oh yeah, that's what. Yeah. What?
Alright,
Nothing. Nothing like that. Well, just this. Oh, spider.
Alright, you don't have a warm up. Grab a warm up. Can that be? Can that be? Hey, Tanner.
On the count. Six.
Alright, let's put the food away. Michael, change your direction.
He's got it, right? No, he's got it.
I got lead.
You know what that's
I can. You want to write with lead?
You should tell us.
Alright. Let me, put the attendance on.
Yeah.
Yeah.
You know who he is?
I don't know.
Sean, who are you?
I was watching someone in class. I'm here. Come on, me. Here. Thank you.
Alright.
Sorry.
Alright, hopefully you're working on the attendance, I mean the warm up.
I remember. I'm sensitive.
I'm telling you, the nigger.
Hey!
Hey, Mr.
Congratulations.
Language, sir. Mr. Lopez, do you have any water bottles?
I sure don't, sorry.
Does anybody in here have any? You do? Come on, man. Wait, Mr. Lopez, this video is on YouTube? But like after the live, does it stay on there?
Yeah. Alright, let's go ahead and get started. All right. All right, here we go. If you don't have a warm-up, make sure you get a warm-up. It's on top of the printer. Just a reminder that we are live on YouTube for those students that have been out. Last week I had several students out. I was averaging about 8 students per class.
Only 8?
Per class. So, well actually it was like 7 per class. So it was like 35 students that are out last week. So what I'm doing is I'm experimenting and putting the lesson on YouTube. It is public at this time, but when class ends and I upload the video, I will go from public to unlisted, meaning you cannot find the video or the notes or anything like that if you do just a regular search. The only way you can watch the video is with the link, and the link is on Google Classroom. All right? So, for those students who were out last week, you really didn't miss much. All we did last week was benchmark for 2 days. Then we had 2 foggy days, and then the one day that we did have, we did arithmetic sequence. So you really didn't miss much. So you got lucky on the week that you missed.
Mr. Lopez, is that arithmetic sequence supposed to be that easy?
Yeah. So for those of you who did arithmetic sequence at home, it's not a hard topic. All you're looking at is a set of numbers, and they're arranged in a specific order. And you have to determine, are you adding by a positive number, or are you subtracting or adding by a negative number? And then you just try to figure out what the next term is, right? So it's a pattern that we're looking for, and then we're just filling in the blanks. Alright, and then we ended the class with writing the equation. Now the equation part is the most important part, but we're not doing any calculations yet. All we're doing is just writing equations, and then tomorrow we'll get to the calculations. Alright, before I forget, is there anybody that did not turn in the assignment, the last class that needs to turn it in today? The arithmetic sequence assignment. Some of you turned it in, but quite a few you did not. Alright, you can still post it online if you want. Anybody else? Anybody else? Can I see your names on it? Anybody in the back? The back? No? Alright. Now what we're going to be doing today is the geometric sequence, and it's very similar to the arithmetic sequence. But there's a slight difference. So the increases and decreases aren't going to be by adding or subtracting. We're actually going to be multiplying for that. So here we go. The objective. All right, today what we're going to do is determine if we have a geometric sequence or not. Alright, just a simple yes or no. Then we're gonna go into it and identify the first term and the common ratio. What's the multiplier? Alright, after that, after that, we're going to determine the next three terms and then write an explicit equation. Now, again, the explicit equation part, that's the most important part, because that's what you have to learn as a math 1 student. Alright, and then we have to use that to build on it and make functions. Alright, here we go. Alright, let's look at the warm-up. The warm-up. Same as we did on Thursday. All you're doing is trying to figure out the next term. Alright? So looking at number 1, I go from having 1 tile to having 4 tiles, then to 16 tiles, right? To 16 tiles. If I were to continue this pattern, what would be the next thing? What the next figure look like?
8 times
8 by 8. So good. So 8 tiles by 8 tiles, which means you would have how many total? 64. So 64. All right. So I go from 1 to 4 to 16 to 64. All right. So what I'm doing is what? What's happening? Can anyone explain what is going on?
8 times 8.
Do what?
8 times
8 times 8, but how'd you figure out that it was an 8 by 8?
That's 4.
Alright, so 4 is the multiplier, so I'm multiplying by 4 each time. Alright, good. Alright, next one. The happy faces, the smiley faces. Now, if you want to draw these smiley faces, you can, or you just tell me how many. I'll give you the next, and it's fine, the number is fine. What is that number?
54.
54. How'd you get 54? It is correct. It is 54. How'd you get 54? You are right.
6.
What?
6 by 6.
Alright, so, alright. But how'd you come up with 54 when they said what was the next one? You just shouted 54. You are correct. It is 54. But how'd you get it? Or, yeah, so I heard the answer. Go ahead, David. Alright, multiply by 3, right? Multiply by 3 each time. I go from 2 to 6 to 18. I'm multiplying by 3 each time. Alright, next one. I go and I start with the person at the very top, right? This figure looks like a person. So there's one figure at the very top, then there's a split, the 2. There is a split to another 2. If I continue this pyramid looking figure, how many would be at the bottom? How many would be at the bottom? I have one answer. You know what you get. How many? What's the number? So it goes from one person to 2, right? Then this person splits up into 2. Splits up. If I continue the pattern, then I would need to split these figures into 2. So then how many would you get? You get 8. Alright, so you'll get 8. Alright, so that's split to 2 to 2 to 2. Alright. There's the warm-up. Alright, so you're going to keep the warm-up. Again, you're going to keep the warm-up. Those are your notes. Alright. In my last class, I said it like 4 times, and then at the middle of the class, some 3 or 4 people asked, what are we going to do with the warm-up? You're keeping the warm-up. Those are your notes. Alright, we're going to write notes now. Alright, let me just go ahead and just show you the whole thing. That way, some people write fast, some people do not. Alright. Number 1, or first thing, is we're going to define what a geometric sequence is. Alright, so geometric sequence is a sequence in which a ratio r can be multiplied to each term to get the next term. You're gonna notice that these notes are very similar to the arithmetic sequence. The only difference is instead of saying ratio or difference, now it says ratio. Instead of saying adding, now we're multiplying. Alright, so geometric sequence is a sequence, and we're multiplying to find the next one, to find the next term. You write what you want to write on that. If you already, you even simplify it. You don't have to write it exactly like that. It's up to you. Alright, so again, so geometric sequence is a sequence in which a ratio R can be multiplied to each term to get the next term. That ratio is called a common ratio, like it's the common number that we're multiplying each time. And then to find the common ratio, you're going to divide two numbers, right? And I'm going to go ahead and write that down here. So I'm dividing the second term by the first term. So the second term by the first term. So if you just want to write second, divided by first, you can. Sorry, my tablet just gave up after second period, so that's why I haven't posted the notes. I thought it was going to start working again. It's still not. So I'll post these notes after seventh period. I'll post it. All right. So to find the common ratio, you're going to multiply. You're going to divide the second term by the first term. You're going to get a number, right? And then you're just going to double check, make sure all those numbers or the sequence does have that common ratio. That common number is being multiplied by. If you're increasing, it's a number bigger than 1. If you're decreasing, then it's a fraction or a number smaller than 1. And what I mean by smaller than 1, between 0 and 1, between 0 and 1. And then you can multiply by negative. And when you do that, you're going to see there's a pattern. And we'll talk more about that when we get to it. But for now, geometric sequence is a ratio that can be multiplied to each term. That ratio is called common ratio. To find the common ratio, you divide the second term by the first term, and you'll have your R, your common ratio. So I'll give three examples, and I'll show you one where you can use the formula and one where you don't really have to use the formula. You kind of see the pattern. All right, you want to still write it? You want to still need more time with this? You good? All right, Sean, you go. All right, let's do an example here. So here's my sequence: 4, 8, 16, 32, 64. And then for students that were not here last week, the first number of the sequence, a sub 1, that's your first term. A sub 2 is the second term, that means the second number in the sequence, followed by the third, fourth, and fifth. All right, so looking at this. How is it's being increased, but it's being increased by what? How many? By if I add 4 to the first set, that's correct, 4 to 8. But then you'll notice that 8 to 16, there's a difference there. So yes,
Can you ask me from that?
when you get back. So I'm multiplying by 2, right? So I'm multiplying by 2. So each time, as I go through this, 4 times 2 gives me 8. 8 times 2, 16. 16 times 2 is 32. 32 times 2, 64. So each time there's a multiplication, and that multiplication is by 2. Multiplying by 2. And the 2 is your common ratio. The 2 is the common ratio. Alright? Any questions there? Any questions? So if I want to find the next one, I just multiply 64 times 2. Alright, and that's how I find the next one. And then the next one after that, 128 times 2. Alright. Any questions up to this point? So again, it's very simple. For those of you who were here on Thursday, this looks very similar to the arithmetic sequence. But the only difference, again, is that the arithmetic sequence I'm adding, I would add by 4 each time. In this case, I'm multiplying by 2 each time. Alright, ready to move on? You guys still ready? I'm gonna move on. Unless someone needs more time. Does anyone need more time? Alright, so let's look at a couple more examples. Now we're gonna look for the first term and the common ratio. Alright, so it's number 1. I should have put some more space between 1 and the 2. So it goes 2, the sequence goes 2, 8, 32, 128, 512. So what is the first term? What's the first term here? McKenna B. What's the first term of the sequence? For number 1. It goes 2, 8, 32, 128, and 512. What's the first term? What's the first number you see in that example? 2. Alright, so 2 is the first term. Alright, to find the common ratio, what is the common ratio? Can someone tell me what the common ratio is by looking at this?
Times 4.
Times 4. I'm multiplying 4 each time as I move along. Alright, if for those of you who cannot see it, what you do is you apply the formula. Take the second number divided by the first number. So 8 divided by 2. What is 8 divided by 2? It's 4. So I'm multiplying by 4 each time. So my ratio is 4. Alright? Any questions there? No? Alright, let me do one more. Pretty quiet. Alright, here's another one. I go from 225 to 45 to 9 to 9/5 to 9/25. So in this case, I'm decreasing. Alright, so here you go. First term. What is the first term here? First term. 225 is the first term. Correct. Now, what is the common ratio? What's the common ratio? What's going on here? If you don't have the exact number, just tell me, just give me a verbal description. What do you think is going on? What do you think is happening? It's decreasing, and how am I decreasing? So we'll say we're dividing. We're dividing by how many? By 5. We're dividing by 5. Alright? So we're dividing by 5. Now, to set this up, I'll take the second number. Questions there on finding the common ratio? I don't see any hands up. Just a reminder that you have to check all the numbers, make sure that they do work, that I am dividing by 5 each time, which they are. Or multiplying by 1/5. Or multiplying by 0.2. Alright, so we completed the first 2 objectives. Now the next objective is to find the next 3 numbers. Alright, so the first example here, I have 1, 2, 4, 8, 1, 2, 4, 8. What is the next number? Kanye, what would be the next number? I go from 1 to 2 to 4 to 8. So it was 2, 4, 8. What would be the next?
After 8.
After 8, yeah. 1, 2, 4, 8. So it's geometric, meaning I'm multiplying by a certain number.
12.
So not 12, not 13, but you're getting closer. 16! 16. Alright, so it's 16. I don't know what's going on here. Alright, so it is 16. So 16, okay, after 16, it's what? What's after 16? 32. Alright, what am I multiplying by to move along?
2.
I'm multiplying by 2 each time, and then 64.
69.
And 64. Alright? So 16, 32, 64. Alright, look at the next one. The next one. I go from 5, negative 15 to positive 45 to negative 135. So I'm going to have to look for a common number that's being multiplied to move along on this sequence. Alright, anytime you have a positive, negative, negative, positive relationship where it goes from positive to negative, back and forth, means I'm multiplying by a negative number. What am I multiplying? What am I multiplying to move along from going from 5 to 15? By what? I'm multiplying by negative 3. By negative 3. Now again, for those of you who forget how to do this, you just take the second number, negative 15. Take your second number, you divide it by your first. Negative 15 divided by 5. Negative 15 divided by 5 is negative 3. Alright, so I should be going back to a positive number, then back to negative. Positive, negative. Alright, so positive would be 405. Alright, so 405. 405 times a negative 3 will give you a negative 1215. 1,215. 1,215. 1215 times negative 3 gives me 3645, so 3,645. There it is. Alright, so again, don't overthink this. Arithmetic, you added, here we're multiplying.
Why does that look like a 6?
Which one?
The 3,000.
Oh, it's supposed to be at 45. Alright, let's go to the next one. Alright, so the first few examples, we're increasing. Alright, so let's look at one where we're decreasing. I go from 4,000 to 2,000. 2,000 to 1,000. 1,000 to 500. What's going on here? What is going on here? What's the next set of numbers? So what will be the next set of numbers and how did you get it? Alright, Karis. Follow on you. So what will be the next number, Karis? Can you see it? Goes 4,000, 2,000, 1,500. Then what else? What's the next one? Do you need your glasses?
Yeah, I'm trying to find
100. You're close.
150.
Close. Not 150. Should be 250. So cutting it in half. Kara, so cutting it in half. Half of 500 is
250.
250. Half of 250 is 125.
125
And then half of 125
is
62.5.
okay.
Alright? So that's all you would do here. And again, use a calculator, use a calculator on your Chromebook, decimal scientific, you're multiplying by 1/2 or you're multiplying by 0.5, whichever one. If you want to put divided by 2, you put divided by 2, but just understand that when we build functions, I need a multiplier, so you have to put 0.5. Alright, questions? We're almost done with notes. Alright, so the objective, we figure out what geometric sequence is, we found the common ratio, we defined it, we found the next three terms. The last thing we have to do is write an explicit formula. So write a formula, or write an equation. Alright, ready? Next one. Next one, ready? Alright. Let me go ahead and just show you all everything, and I'll talk about it here in a minute. Alright, so go ahead and write this down. This is the formula, and then parts of the formula, and then we'll talk about it here. Alright, whoever's playing music, turn it off. Alright, so your formula is like this. We're not doing any calculations. All we're doing is setting this up. So we have a sub n is equal to a sub 1 times r raised to the n minus 1 power. So that's an exponent. N minus 1 is an exponent. Alright? A sub 1 is, again, the first term of the sequence. R is the common ratio. That's the multiplier that I'm multiplying each time. A sub n is the solution for a specific term. And then n is just a specific number. So whatever term I'm looking for, I'm going to use that number, plug it in, calculate, and then I get my a sub n. All right, who's playing music?
Yeah, trash ass music.
Oh, it's outside?
Not curious. You're down.
Alright, so let's write this out really fast. So again, we're not calculating, we're just setting this up. Alright, so to set this up, I have a sub n,
But it's dude back, I gotta pee. God damn.
Alright, there it is. Alright, so I have a sub n, so I'm just going to write this down really fast. A sub n is equal to, write this down please. A sub n is equal to the first number of the sequence, a sub 1, which is 2. Instead of putting a dot, I'm going to go ahead and put parentheses to multiply. I just want to form this habit of putting parentheses here. And the reason being is because if you have a negative number, you'll get a different answer if you do not have parentheses. So make sure you have parentheses to get the correct answer. Alright, what is the multiplier? What am I multiplying each time? By. So I go 2 to 8 to 32 to 128. What am I multiplying by? 2 to 8, 8 to 32. I'm multiplying by what? 4. By 4. So 4 is my base. And then in my exponent, n minus 1. Now, if you are plugging this into a calculator, then you would have to have parentheses here as well. So n minus 1 in parentheses. And we'll talk about how to plug this in tomorrow when we get to these types of problems. All right, any questions? Any questions? This is the setup.
Mr. Lopez, how please use the restroom? I have to go bad.
You gotta just wait a couple more minutes, see if he's back.
Bro. I'm telling you, I ain't weird.
All right, let's go into the assignment. The assignment's on Google Classroom. So pull the assignment up in Classroom. It's the geometric worksheet, geometric sequence worksheet. The first 4 problems, all you're doing is just saying yes or no, is the geometric sequence or not. Yes, it's geometric, or no, it's not geometric. Alright, so let's look at the first 4 problems. First 4 problems. Alright, ready?
No, hold on.
Alright, okay, here you go.
I'll go back.
Let's try to miss it all the time. Time to get back.
I take it back, sir.
Alright, so let's look at number 1. So it's a simple yes or no. Simple yes or no. I go from 2 to negative 12. Negative 12 to positive 72. 72 to negative 432. Again, if it goes positive, negative, that means my ratio is going to be an R. Alright, so let's look at this. Is this a geometric sequence? Are all these numbers that I'm multiplying by have a common ratio? Are they a common ratio? So is it yes or no? I heard what?
Yes.
Yes? Alright, so it is yes. What is the ratio to test this out? So, what am I multiplying each time? Each time I'm multiplying by what?
2.
Not 2, another number? By 6, right? To be more specific, I'm multiplying by negative 6 because it goes positive, negative, right? Negative times negative is positive, positive times negative is negative. So the sign switch. Alright, so negative 6. All the way across. Negative 6, negative 6, negative 6. Alright, so that's a yes. Alright, let's look at number 2. Number 2. Alright, so again, we gotta figure out, do they have a common ratio? Is this a yes or no? Yes or no? Again, if you don't know how to do this, take the second number divided by the first number. Second number divided by the first. Alright? When you do that, take the second number divided by the first, what do you get? So the second number divided by the first, 23 over negative 7, which is roughly about 3.28 or 3.29. We'll just say 3.3. Roughly 3.3, negative 3.3. Now, if I do that each time, am I going to get the following answer? So 23 times 3.3, is that going to be 127? Is 127 times 3.3, 623? The answer is no, it's not. decimal. Just because you have a decimal doesn't mean that it's not gonna be a geometric sequence. It just means that, I really have to double check now. Again, just look and assume that they look kind of close, therefore yes. You all right, Sean? We're about to send a search party. You're at 23 minutes. So 55-minute class. All right, so it's yes or no. So go ahead, 3 and 4. Just simple yes, no. For 3 and 4. 3 and 4, yes or no. Yes, no. All right, make sure you're doing this. The more work you do here, the less the work you do at home. So, McKenna, you got it? All right, so we're doing 3 and 4. You're doing 3 and 4. Again, the assignment's on Classroom. Give about 30 seconds, 45 seconds. Alright. About 10 more seconds. And again, just simple yes, no, will be good. Alright, 5 through 8. 5 through 8 is the same thing, yes, no, but this time you have to tell me what is the R. R equals. If it's not a geometric sequence, then just put no and leave it. You don't have to tell me the R, because it's not a common ratio. Alright, so all you do is just tell me, if it is yes, then you tell me the R. I'll give you a hint, there's only one in 5 through 8. Alright, here we go. 1, -6, -36, -20, 216.
Is there enough time or no?
Mr. Lopez,
So what?
can I go?
There's only enough time for one person. Kanye get asked. Alright, so what is the multiplier? What are we multiplying by? What are we multiplying by? Okay, so I heard two answers, a -6 and a +6. Which one is it? -6 or +6? Alright, it's going to be a +6. The reason why it's +6 is because you're not a switch from positive, negative, positive, negative. So it's just going to be +6 and keep them all negative. So, yes, this is a geometric sequence. And my R is equal to 6. So yes, it is a geometric sequence, R is equal to 6. Alright, let's move on to the next one. Here, there's the switch. It goes from negative to positive, back to a negative, to a positive. So here, my R should be negative. If they are all the same, then it's geometric. Alright, what is the multiplier? What am I multiplying by? Sydney, what am I multiplying by? I go from 4 to 12, 12 to 36, 36 to 108? 3. So, my answer for this each time is I'm multiplying by 3 each time. To be more specific, by -3. So, number 6 is yes, and R is equal to -3. Alright. There's 7, 8, same thing. Hint, one of them is not in geometric sequence, so you don't have to find the R. The other one is, you do have to find the R.
Let's make it up, 35 or 40.
40. Or 45. No, 40. Alright, here you go. 9 through 12. 9 through 12. Alright, 9 through 12, I'm not tricking you or anything. They're all geometric sequence. What you're trying to figure out is the next three numbers in the sequence, the next three terms. Alright, so what are the next three terms here? So I go from -2 to +4, +4 to -8, -8 to +16. So if I continue with this pattern, it should go negative, positive, negative. Negative, positive, negative. Alright, so let's look at this. What am I multiplying by each time?
4.
By 2. Multiplying by 2 each time, right? I'm doubling. I'm going up by 2. By multiplying by 2. Alright, so times 2. But to be more exact, by -2. Alright, so multiplying by -2. And just put a little X there. Alright, so if I continue the pattern, the next number should be a negative number, -32.
What the?
Positive 64. Alright, pay attention right here. And then from -32 to positive 64, and then back to a negative number, -128. Alright, so you take the previous number and you multiply it by 2. Alright, so like 64 times -2. And it gives you your 128. Alright. Then go ahead and do number 10 through 12, 10 through 12. Through 12. Again, you're just filling in the next three numbers, 10 through 12. What are the next three numbers? You're probably going to need a calculator for this, so just use Decimal Scientific and just multiply. Multiply by -2. Multiply by -3 or 3. Multiply by 4. Using a calculator. Alright, let's do number 13 and then another problem, and we'll call it a day. 13 plus one more. Alright, number 13, it wants you to set up an explicit equation. Alright, find the explicit formula for this. Alright, so you're gonna have a sequence, -4, -20, -100, -500. It doesn't switch back and forth, so that means my ratio is gonna be, just gonna be one number, or a positive number, I should say, positive number. Alright, so here we go. Alright, so here's the formula again. A sub n is equal to A sub n is equal to A sub 1 times R raised to the n minus 1. Raised to that power. Alright, I'm going to put the R in parentheses and the n minus 1 in parentheses here. Alright, we're not doing any calculations today, so we're just going to put A sub n to set up. Is equal to the first term. What is the first term in this sequence? What's the first number you see? Lisa, what's the first term?
-4.
Thank you, Lisa. -4. Now, I'm going to multiply, and I'm going to make a start with doing this habit where I'm going to go ahead and put parentheses here. And then what am I multiplying by? What is the change each time? What's the change? Well, how many am I decreasing by here? Or the numbers are increasing by something, the absolute value. Put right stuff. By 5. So I'm multiplying by 5. And then the n minus 1, you could leave this exponent as, without parentheses, you can put in parentheses. But when you use a calculator, it requires parentheses if you're going to put both these little terms in. So the exponent. So n minus 1. Now again, the reason why I put parentheses there is so you can start building a habit of using parentheses when you're typing in this into Desmos. Alright, any questions? Questions? Alright, I have time for one more. Which one do you want me to do? Pick a number between 13 and 18. 14 and 18. 14 and 18, yes.
15.
Alright, 15. Here's 15. Alright, so I'm going to go ahead, I'm going to skip the formula, so I'm just going to write the equation out. So I have A sub n. So you get it. Alright, so A sub n is equal to the first term. The first term is -4. -4. What is the multiplier? What am I multiplying by? I'm multiplying by -6, so I'll put -6 in. And then n minus 1 is my exponent. That's it. Alright, if you're done with the geometric sequence, I've selected. If you're not,
What you missing on the other day?
alright. Go ahead, have a seat, have a seat. You don't have to crowd the door. Arithmetic or geo? Arithmetic, yeah. Your name's on it. Alright, step away from the door, step away from the door, have a seat. Have a seat, step away from the door. We're not lenient to everyone is sitting down, so have a seat. Again, we're not lenient to everyone is sitting down, so find a chair. Find a chair. Kanye, find a chair.
First time will be abolition.
Alright, find a chair. Need a chair. you're gonna grab the boys volleyball. We have practice tonight at Rio Vista. Check the Instagram.
Oh, someone's degree deodorant. She forgot it again.
Grab a warm up. They're on top of the printer.
Do I have enough time to go to the bathroom?
Sure. Let's grab a warm up. Just grab a warm up. Yep. Just grab a warm up, grab a warm up. If you haven't done so, go ahead and grab a warm up. Warm ups are here. We're on top of the printer, 1 or 2. Warm up. then work on it while I do the attendance. Warm-ups are on the printer. It's same as the last warm-up where you try to figure out what's the next, how many units or how many figures on the next one. And then, you can draw it out, however you want to do it. Nice, everyone's here, there, not this group, I'm missing quite a few. Sabrina. Isaac, no Isaac. Steven, sir. McKenna. Just missing Samantha. All right, continue working on this. Let me just submit. All right, so 1, 2, 3, 4, 5. All right, let's go ahead and get started. Hopefully you're able to do this. If you need a calculator, use the calculator on your Chromebook. No cell phone. Cell phone must be put away. Come around, take it away if you have it out. The assignment we're working on today is the geometric assignment, and that's on Google Classroom. We'll be doing that. I'll answer your warm-up questions here. We'll answer the warm-up questions right before the notes. All right. Just try something really quick. I don't know for what. Why the tablet's not being picked up. Do something really quick and then we'll get started. here we go. I cannot get the tablet to work, so I'm going to write with the mouse. Top of the printer. Alright. I had quite a few students that were out last week. If you were out, make sure that you get caught up. You didn't really miss a whole lot because we did benchmarks on the first 2 days, and then we had 2 days of 2 foggy days, and so only left us 1 day of instruction, which is the arithmetic sequence assignment. So you're gonna have to do that arithmetic sequence assignment. Now, for those of you who did not turn in the arithmetic sequence assignment, I will collect that now. If you have it, I'll collect it. Does anyone have it ready to be turned in? Now, some of you did turn it in, but not a whole lot of you turned this in, so only a few of you did. If you have it, I'll collect it. If not, you will have to turn it in online. Simon, get your feet down, please. All right, anybody else? Those 18 columns, we did about 9 of them in class. 10 of them, like 10 class. All right. Now, for those of you who are out, arithmetic sequence is just a sequence. It's a list of numbers, right? And they move up or they increase or decrease by a common number, right? So I'm either adding by 3 or subtracting by 3, but they all move up by that same number, all right? So it's like counting 2, 4, 6, 8, counting by 2s, 3, 6, 9, counting by 3s. Geometric sequence is something very similar to it, all right? So today we're going to be learning about geometric sequence. The objectives are pretty similar to the arithmetic sequence one, or lesson, the arithmetic sequence lesson, and that is we're going to determine if it's a geometric sequence or not. We're going to identify the first term, then the common ratio. So instead of the common difference, we're doing common ratio. Then we're going to find the next 3 numbers, the next 3 terms. And then we're going to write an explicit equation or use the explicit formula to get this. All right? Questions to this point? No? All right, so let's look at the warm-up first and we'll start taking our notes. All right, in the warm-up, you're given different figures. All right, on the first question, number 1, I have 1 tile, 4 tiles, 16 tiles. If I had to determine the next sequence, what would it be? How many tiles would I have? Do you want to take a shot at it, or do I need to call someone? So it goes from 1 to 4 to 16. So what would be the next one? 1, 4, 16. What would be the next one? Yes.
24?
You're close. You're close. 20. You're close. I am going up. You're close.
28.
What?
28.
28. No, it's actually a little bit more. I mean, it's a significant jump, but it's not like in thousands or in hundreds. 64. All right. You got 64. All right. The answer is 64 tiles. So what I did was, right, I went up 1 and went over across and then complete the square. And this one, I went 2 more up and 2 more across to complete the square. Alright, and the next one, I will go up 4 more, and then you complete the square. Alright, what I'm doing here is I'm doubling doubling the length and the width. So I'm making the number of tiles increase by 4 times. So I go from 1 to 4, 4 to 16, 16 to 64. So I have to multiply by 4. Alright, so it was 64. Alright, that was a little tough one there. That was a tougher one of the 3. Now, let's look at the next question. I think number 2 is I think it's a little bit easier or more straightforward as far as trying to figure it out. Here's the second one. I have 2 smiley faces, 6 smiley faces, 18 smiley faces. If I were to continue this, what would be the next, how many smiley faces would I have in the next one? How many would I have in the next one? Yes, 54. Alright, how'd you get 54? You're correct, it is 54 smiley faces, but how'd you get 54?
Oh, yes. Okay, I knew that 2 times 3 is 6, and 6 times 3 is 18, and 18 times 3 is 54.
Yeah, so multiplying by 3 each time. 2 times 6, 3, or 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, right? Increasing by a multiple of 3, right? Multiplying by 3, by a factor of 3, I should say. By a factor of 3. Alright, here's another one. We have this figure, kind of looks like a person. Alright, a symbol for a person. Then this person goes up to 2, then this one person goes 2, the other person goes 2, so I go from 1 to 2 to 4. Then the next one would be how many? The next, if I were to continue and make this pyramid looking shape, what will be the next row or the next, next row, bottom row? Anyone take a guess? If not, call someone. Anybody? No? Alright, Teresa. So what would be how many, I guess, people, figures would you see on this bottom row? 8, you're correct, there are 8 figures, right? Because the person above, you break them up to 2, right? So as I'm going further down, it multiplies by 2. Multiplies by 2. Alright, any questions there? Any questions? Alright, can someone tell me there's a common theme for each 1, 2, and 3? What's that common theme you saw in 1, 2, and 3? What did we do each time to increase? Yes? Yeah, we multiply each time. So that's what we're going to be learning today. Well, that's what geometric sequence is you're multiplying each time. Let me just give you all the notes here and you can write it down. So you're multiplying each time. So a sequence in which a ratio r can be multiplied to each term to get the next term is called a geometric sequence. The ratio is called common ratio, right? So the common number I'm multiplying each time is a common ratio. Alright? So again, geometric sequence is a sequence in which a ratio r can be multiplied to each term to get the next term. That's the geometric sequence. Make sure you write this down. Alright, so it's a geometric sequence. A sequence in which a ratio r can be multiplied to each term to get the next term. find the common ratio, what you do is you're gonna divide two numbers. Now, I'm going to write with my mouse here, 'cause my tablet's not working. So I'm going to write with this. So what I'm going to do is I'm going to take the second term, a sub 2, and divide it by the first term, which is a sub 1. Alright, so the second term divided by the first term. So you'll see a list of numbers, right? Take that second number, divide by the first number, and you get your answer. So you're dividing any terms that follow it. So they gotta be side by side. The two numbers that you're using have to be side by side, but you take the second one, divided by the first one. So whichever two numbers you decide that are side by side, take the second one, divided by the first one. All right, any questions there? Again, the sequence we're looking at today is the geometric sequence. Geometric sequence, pretty similar to the arithmetic sequence, but the biggest difference is that we're multiplying here versus arithmetic we're adding. Alright, the ratio is with the number we're multiplying by. And to find the common ratio, you take the second term divided by the first term. That is it. Alright, anyone still writing here? Anyone still need more time? Go ahead. The next few slides are going to be examples, and then we'll get into the assignment. So make sure that everyone has plenty of examples. While people are catching up and writing here, if you have a jersey for tomorrow. Tomorrow's a dress-up day, so you get to wear jerseys tomorrow. However, there cannot be any Fresno State jerseys. That's the only exception. So it's a jersey day, but it cannot be Fresno State.
Why can't it be Fresno State?
Because of the games, really. That's why. We have a gang issue here. Not to say that you're in a gang, but people fight for the silliest things. Alright, ready? Next one. Anyone still ready? Anyone need more time? Alright, moving on then. Alright, so let's look at some examples. Alright, to find the common ratio, you don't have to write the whole thing down, just have an understanding of what we're looking at. Alright, we're getting a sequence 4, 8, 16, 32, 64. Alright, the first term of the sequence, a sub 1, is 4. The second term is 8. The third term is 16, and so on and so forth. Alright, so what we'll do is we'll try to find the common ratio. Now sometimes you'll need a formula to solve for it, and there's times where you don't. Alright, some of you can pick up on the pattern. I go from 4 to 8 to 16 to 32. Can anyone pick up on the pattern here? What are we multiplying by? What are we multiplying by? The 4, 8, 16, 32. By what? By 4? Or by 2?
No,
by 2. We're multiplying by 2. Right? So we're multiplying by 2 each time. Right? The first one we added 4, but we're multiplying by 2. Sorry, multiplying by 2. Alright, 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. Now, a lot of you are going to need a calculator for this unit. Almost every one of you will need a calculator for this unit. Again, we're going to use Desmo Scientific. Let's get in the habit of using the one that's on our Chromebook. You cannot use your cell phone as a calculator on the test. So might as well get used to the one on the Chromebook. Desmo Scientific. All right, so let me go back here. So, now if I wanted to use the formula, I'll take the second number, a sub 2. I want to use the formula a sub 2 divided by a sub 1. Alright, second term divided by the first term. So 8 divided by 4 gives me my ratio of 2, right? My R is equal to 2. Alright? Now, again, some of you would need the formula, some of you would not. You pick up on the pattern. Yes? Sure. Alright, next one. Ready for next one? Alright, so the next example, these two examples, once again, a habit of trying to figure out the first term and the common ratio. First term and common ratio. Alright, so here we have the first 2, 8, the sequence of those 2, 8, 32, 128, 512. Alright, can, Jonathan, what is the first term for this sequence? First term for this sequence. What is the first term? So what's the first number you see in that sequence? 2. So the first term is 2. Now, to find the common ratio, again, some of you will need to apply the formula. The formula is the second term divided by the first term. Alright, so what is the common ratio? What's the common ratio? Start out. Yeah, Jan. What's the common ratio? What is the second term is 8, first term is 2, so 8 divided by 2 is what? 8 divided by 2, what? You said, I thought I heard you say it. 4, yeah. 4, so the answer is 4, right? My common ratio is 4, right? Each time I'm multiplying by 4. Each time I'm multiplying by 4. All right, next one, question number 2. I have 225, 45, 9/9, and lastly, 9/25. All right, so I'll go from 225 to a decimal or a fraction. All right, so I'm decreasing in size. All right, here we go. Ready? First number in this term, sequence. First number in the sequence. Alex, what's the first term? For number 2.
Open number 225.
225, correct. 225. Now, if I were to solve this for R, what would R be? What is R? What is R? Now, set up the equation if you have to. So what is R? R is what? Take the second term divided by the first term, and you get what? What do you get? Second term divided by first term is what? Second term divided by first term. Alright, second term is 45, first term is 225. What's 45 divided by 225? Alright, 0.2. 0.2 or 1/5. That one, when we do write equations for this, if you want to use a decimal, you can use decimal 0.2. If you want to use a fraction, you can use a fraction. Now, the test, I think they're going to ask for a fraction. So to convert, if I type this into Desmos Scientific, 45 divided by 225, you get 0.2. Right? It equals 0.2. Now, if I want to convert it back to a fraction, to the right of your decimal answer is a little figure that looks like this, a little symbol, a fraction symbol. You click on it, it will convert your decimal back to a fraction, which is 1/5. All right? Now, it's up to you however you want to write it on your equations. 0.2, 0.2, or a fraction, it's totally up to you. I'm not going to tell you one way or another. Most students like to use decimals just because it's easier to type it into the calculator versus a fraction. Alright. Now, one more thing before I forget. To make sure you have a geometric sequence, you have to verify that the common ratio is the same, right? The ratio is common for each one. So I'm multiplying by 0.2 all the way through. Right? Multiplying by 0.2 all the way through is the same thing as saying I'm dividing by 5. Are you dividing by the denominator? 225 divided by 5 is 45. 45 divided by 5 is 9. Alright, so that's why I go from 45 to 9. I divided by 5. Alright, any questions there? Alright, we did the first three things on the objectives. We defined geometric sequence. We found the common ratio, the first term. Alright, the next thing on the objective list is to find the next three. What are the next three numbers that come along here? Alright, so I go from 1 to 2 to 4 to 8. I'm increasing by multiplying by a certain number. So what am I multiplying? What would be the next number? Let me ask you that. What would be the next number? Anybody? Next number. 16. Alright. So 16 is correct. Followed by what? Followed by what? 16, then what? 32, then what? 16, 32, and then what's the next one? 64, right? 64. So 16, 32, and 64. Alright, 16, 32, and 64. So let me write this down here. So 16, 32, and 64. Alright, how do I get those numbers? Because I'm multiplying by 2 each time. Alright, so here's a one where I go from positive to negative, back to a positive, back to a negative. Alright? So here is when I multiply by a negative number. I'm multiplying by a negative number. What is that negative number that I'm multiplying by? Negative 3. Negative 3 times positive 5 is negative 15. Negative 3 times 15 is 45. Negative 3 times 45 is 135. So if I were to continue along with the pattern, multiply negative 3 by negative 135, I should get positive 405. Alright, so it goes positive, then back to a negative. Multiply this by 3, 405 by 3, you get 1215. 1,215. Back to a positive, this will get to 36, 45. And how did I get this? Because the common ratio is negative 3. I'm multiplying by negative 3 each time. Multiplying by negative 3 each time. Alright. Next. 4,000, 2,000, 1,500. This time I'm decreasing. How am I decreasing? And then what will be the next set of numbers? Alright, so let me call on someone. Alec. Alec, what would be the next number? What do you think the next number? It's smaller than 500. Give you that much. Give you that hint. What do you think it would be? What is smaller than 500? If you don't know the exact number, just tell me what's going on from 4,000 to 2,000, 2,000 to 1,000, 1,000 to 500. You tell me that, then I can help you out with this. What do you think is going on? Can you see the pattern? 100. The answer is more than 100. That goes here. There's something else. Brooklyn?
250.
250. How'd you get 250?
Dividing 500 by
Or divided by 2, right? I took half, right? I took half of 4,000, half of 2,000, half of 500, half of 250 is 125. Right, what I'm doing is dividing by 2, right? Divide by the denominator, or you multiply it by the fraction, 1/2. I'm taking in half of something. Alright, you could say 125 over 2 or 62.5, it's up to you. I'm not going to mark it wrong if you put 125 over 2. But what I'm doing is taking half of it. I'm multiplying by 1/2. Alright, or dividing by 2, however you want to say it. Alright, any questions? Any questions? Alright, so again, we determine what a geometric sequence is. Geometric sequence is when I multiply, right, to get the next number, and it's multiplied by the same number. That same number is called common ratio, taking the second term divided by the first term. Alright, that's the common ratio. Then we found the next 3, which we just did that. We found the next 3. We just continue with the pattern, fill in the blanks. Lastly is we're going to learn how to write the explicit formula, the explicit equation for this. Alright, so the equation is as follows. A sub n is equal to a sub 1 times r raised to the n minus 1 is the exponent. N minus 1 is raised to a power. Alright, a sub 1 again, remember it's the first term. R is the common ratio. R is the common ratio. A sub n is the solution for a specific term. Solution for a specific term. And then n is the specific number, right, that we're looking at for the specific term, right, that term that we're trying to define. Now, this, again, like the arithmetic sequence, all we're doing is just filling in the blanks. We're not going to solve, so the a sub n is equal to the first number. The first number of the sequence is 2 times, now you can put a dot, but I'm going to go ahead and just start creating this habit where I'm just going to put parentheses here to represent multiplication. And the reason being is because if it's a negative number, it has to go in parentheses. So the r is whatever it multiplies by. Alright, I'm multiplying by 4 each time. So 4 will go here. And then n minus 1. Again, you don't have to have n minus 1 in parentheses. Because if I'm trying to find, let's say if I'm trying to find the 5th term. When I'm trying to find the 5th term, all I need to do is just work out in my head. 5 minus 1 is 4. So it's 4 raised to the 4th power. And we will worry about that tomorrow. That's tomorrow's assignment. Alright. So 2 times 4 raised to the n minus 1. That's it. That's all you get to do. Just set up. Are there any questions? Are there any questions? No questions? Alright, those are your notes. That's all we have for notes. We're going to do the assignment. So if you need another paper for your assignment, I have some more. Alright, let's do the assignment now. You have to mark Maya next. Maya's not here, and I forget about her. Yes. Yeah. All right, here we go. Yep. All right, so the assignments on Google Classroom, the first 4 questions is just yes or no, just like the arithmetic sequence. Yes, it's geometric, or no, it's not geometric. That's it, that's all I'm looking for. Yes or no. Yes, it's arithmetic. All right, yes, it's geometric. No, it's not. All right, so here we go. 2, -12, -12 is 72, 72 is 432. I have to find a common multiplier that goes into all of these in order for it to be a geometric sequence. All right, is this a geometric sequence? Yes or no? Anybody wants to take a guess? Yes or no?
No.
If not, call on someone.
No, it's not.
All right, so I had 2 no's. All right, so let's see. The equation says you take the second number, -12, and you divide it by the first number, which is 2, which is my ratio would be -6. All right, so 2 times -6. What's 2 times -6? 2 times -6 is -12, so that's correct. What is -12 times -6? -12 times -6. -12 times -6. -12 times -6 is 72, so that's correct. What's positive 72 times -6 is positive or negative 432, so that's correct. So then my answer is, yes, it's geometric. So the answer is geometric. All right. Let's do the same down here. Let's just go ahead and put in the formula, 23 over -7. 23 over -7 is going to give you a decimal. We'll just say 3.3. So -3.3. We'll just round up. All right? -3.3. All right, so here we go. If I take each time and I multiply it by 3.3, each one, all right, from the previous one, 23 times 3.3, I should get 127. 127 times 3.3, I should get 623. But I don't, so this is a no. So remember, it has to be a common multiplier. It has to multiply by the same number. Any questions there? Any questions? I'm going to let you do 3 and 4 on your own. So it's either a yes or a no. Yes or no. Now, just because it's a decimal answer doesn't mean that it automatically be no. You just have to double check it. The chances are it could be, but double check it. I'll try to give you, if it is like decreasing, I'll try to give you like, where I'm divided by 4, 0.25. Divided by 2, 0.5. That's the decimal. All right, let you work on those 2 problems really quick. These are what can change the attendance. Yes. Let's hold up. We leave in 13 minutes. Can you hold it? Let's move on to 5, 6, 7, and 8. 5 through 8. Same thing, yes or no, but this time you're going to actually tell me what the R is. If it's a yes, you give me the R. If it's a no, then you don't have to say anything. Just put no, that's it, and just stop. And you're good. All right, let's start with the first one, number 1. All right, number 1, I go from -1 to -6, -6 to -36, -36 to -216. They're all negative, so my R is going to be a positive number. R is going to be positive. If it's negative, then you'll switch back and forth like number 6. You'll switch back and forth. All right, is this geometric? What am I multiplying by each time? 1 times what gives you -6? Or -1 times what gives you -6? What is that number? If not, we just write the equation over here. Can you write the equation?
6.
Alright, so it is 6. -6 divided by -1 is 6. Alright, so this is -6, or +6, I should say, +6. All day technology. Let me just use my finger. Alright, so it is 6. So -6 divided by -1 is equal to 6. Alright, now I just got to make sure that it does multiply each time. And if it does, then we're good. And it does. So yes, it is geometric. Yes, it's geometric. Not only is it geometric, it's also R is equal to 6. R is equal to 6. Alright, same thing here. We gotta just try to figure out what am I multiplying by each time. Alright, here it has to be negative because it switches from negative to positive, positive, negative. Negative, positive, back to negative, positive. What am I multiplying by? Alright, again, if you forget, just take the second number, divide it by the first number. Alright, which is what? What is that? What is 12 divided by -4? 12 divided by -4? -3. Alright, so I gotta just make sure that when I do this, it does, -36 times -3 should be 108. If so, then this is yes. And the R is -3. Common ratio is -3. Alright. 7 and 8, I'll let you do 7 and 8. Again, just yes or no. If yes, give me R equals something. If it's no, then just leave it blank. Just put no. Alright, we're almost done. Got 9 minutes left. Let me give you about 30 seconds to answer one more problem, then I'm going to jump to the next section, number 9. The next section, number 9. Alright, the next section is you find the next three terms, So I need to find after the 16, you'll get a number, after that number, you'll get another one. So you have to multiply by something. Alright, so I go from 2, 4, 8, 16, so what am I multiplying each time? What am I multiplying each time as I go through this? What am I multiplying by? Somebody. Multiply by what?
-2.
-2. Multiplying by -2 each time. -2 times -2, +4. +4 times -2, -8. Alright, 9 through 12, I'm not tricking you, just find the common ratio and use it to solve the next three. Now to solve the next three, I take 16 times -2. And you get -32. So just make sure you put -32. -32 times 2, +64. Then +64 times -32, or -64, sorry, -128. Alright, that's it. Alright, -32, +64, and -128. Those are the next three. Alright, I'll give you some, about a minute or two, just kind of answer a couple of more questions on 5 through 8. And then after a minute, I'm going to go ahead and do the last section. Alright, a few more seconds, and then the last section. Alright, the last section, 13 through 18, all you're doing here is writing the explicit formula, alright? So remember the formula goes like this: A sub n is equal to A sub 1 times R, and then n minus 1 is your exponent. Okay, if you don't put R in parentheses, I will put R in parentheses just to form that habit. Alright, so A sub n is equal to the first term. The first term is -4. I'm multiplying it by the ratio. What is the ratio for this one? What am I multiplying each time to get smaller or larger, however you want to look at it? Smaller if you're looking at with the negative number, larger if you're just looking at just the numbers. What am I multiplying by? Multiplying by 5, so 5 would go here inside the parentheses. So it's the outside number times the base, and then put the base in parentheses. Then the exponent is just n minus 1 as the exponent. That's it. Any questions? Questions? Alright, now, like I said in the past, this first quiz, the majority of the students end up getting an A on it, and they're locked in with an A for the first few weeks of school. Again, but in order to get an A, you have to understand what's going on. It's not a hard topic to do, but it's something that you do have to take some time and get some practice on it. Alright, so continue working till the bell rings. Don't worry about the Chromebooks. I'll get the Chromebooks here. Just continue working. If you're not working and you're done, then just go ahead and put the Chromebooks on top of the Chromebook cart. You don't have to plug it in, just put it on the Chromebook cart.